And we're live. Good morning, especially to you, Ravi, and good afternoon, good evening from wherever you are. And thank you for joining us for HashiTalks Deploy in our second year. I'm super excited to have you all here. While we give people a chance to get settled, we have a couple of important things to alert you to. One, if your morning is really early, like 6 a.m. kind of early, get started on caffeine now. It's important. You will want to be awake for the next few hours because we have amazing content. Now, with that being said, let us know where you're from. And another quick reminder, this is a professional event, so we have a community code of conduct. And it goes like this. Be respectful, be kind, and be considerate. Be inclusive and patient. Really, all that simple. If you have any questions, if you see something that doesn't feel right, if you read something in the chat, no matter if you're joining us from LinkedIn or YouTube, let us know. We have moderators on standby who will happily figure out a solution to this. Usually we don't have any of these, but just let us know. This is supposed to be inclusive for everyone, and you're part of making that happen. So I think with those items out of the way, I would say let's get right into our first session with Cassie on using Waypoint to easily deploy to the 3 major cloud providers.
Hello, and welcome to my talk on how to use Waypoint to easily deploy to all 3 cloud providers. My name is Cassie Coyle. I'm a software engineer at HashiCorp, and there's my Twitter, GitHub, and website information for those of you that want it. As an overview, today we'll be going over what Waypoint is and how to use it. I'll be actually using it in the demos to deploy my app to AWS EKS, GCP GKE, and Azure AKS. And then, of course, we'll be going over some learnings because who doesn't have learnings along the way? Before I get into what I'll be talking about today, I wanted to preface that by going over a common problem we face as software engineers. Let's pretend I'm an application developer. I build apps. I want to build, deploy, and release my app, but occasionally get frustrated by the lack of consistency, say on my team and by other teams. You can build different ways. There's no standard between app tools. You can build with Docker and package the application and then publish the image to a container registry. One team may use Docker for testing and then Harbor, or another team may do it differently. Teams could even switch tools. And then on the deployment front, you could have different custom scripts per team, and you could deploy the container to Kubernetes or to ECS, and you have different plugin integrations. And then on the release front, you can't release cross-platform in the same way. There's just a lot of overhead. Now that we've looked at some of the common problems we face as software engineers with the build, deploy, and release phases of our applications, let's look into Waypoint and what it is, a solution to these problems. So Waypoint is a tool to deploy, manage, and observe your app through a consistent abstraction of the underlying infrastructure. And there's a great illustration below for you to see. Developers don't need to know the underlying infrastructure with Waypoint. Developers can write the app in the given language, say Go. And then that middle layer, you use Waypoint and write an HCL file, and then you can deploy using Waypoint to a platform of your choosing. Waypoint supports many platforms, such as Kubernetes or ECS, to deploy applications. It is very easy to change the platform target as well. And a typical build, deploy, and release workflow could require many configuration files, but Waypoint handles the workflow in a single file called waypoint.hcl. And here's another illustration where you can see we can build, deploy, and release your app using Waypoint in a consistent approach to delivering your app. So again, you don't need to know the underlying infrastructure. It's one consistent method and one HCL file. So here's a Waypoint HCL file example. It's very simple. You have your project XYZ, app hello world, and you have your build, deploy, and release stanzas. So the build stanza is to create an artifact from the application source code. There are a lot of supported artifact formats such as container image, VM image, or whatever others. So you build your Docker image and store it into a remote registry, maybe hosted by Harbor, or use a Docker registry. The deploy stanza is to stage the created artifact onto the Kubernetes cluster. The artifact or the application is deployed in a deployment, but it doesn't receive traffic yet. And then the release stanza is to enable the deployment to expose the application. So the goal is to make the application ready to receive traffic. And getting into using Waypoint, typically you'll run, your Waypoint init first, and there's the output of what running that could look like. So it checks if your config files appear valid, connects to the Waypoint server, and then registers with the server your project and apps. And then, if you have pipelines, those are also registered with the server, and your project is initialized, you are good to run Waypoint up. So what that looks like is right here, kind of similar. So I grabbed a few snippets of what a Waypoint up looks like, but you can see the build, deploy, and release steps there. So I built my app through Kaneko, produced the Docker image, and pushed it. Kaneko, if you don't know, is an open source tool that allows users to create container images in their Docker file without root access. And then it deployed my app and released it. And we'll see that a little bit later on. I did want to note that I am specifically using HCP Waypoint over our open source version of Waypoint. It is currently in public beta and is a HashiCorp managed SaaS solution. And again, it is that continuous delivery tool that automates and simplifies the process of deploying your web applications into your infrastructure. And a benefit to using HCP Waypoint is that it allows you to manage your application lifecycle without maintaining a Waypoint server and the associated infrastructure. Now, I'll get into my 3 separate demos by showcasing some use cases you might have as a software engineer deploying your apps to 3 main cloud providers. Let's pretend I'm an application developer. I just finished building my app and I need to get it deployed to AWS EKS, but I don't really do this that often. I really do not want to write a deployment manifest and figure out how to get it all done. I did a bit of Googling to find a tool to solve this problem, Waypoint. I played around with Waypoint in my free time and decided to put it to use and write an HCL file to deploy my app to AWS. As a prerequisite, I did do a runner install. So Waypoint uses runners to execute operations. Every operation that Waypoint runs, say a build, deploy, and release, is executed by a runner. So the runner install is necessary as I want Waypoint to be able to deploy to my cluster. And I did, again, create this ahead of time, so we'll see that shortly. With the runner install, it does create a few resources in my cluster. So the runner itself lives as a pod, which I'll showcase. And the install command creates a service account and a role binding such that the runner can itself, along with an on-demand runner that it spins up, have cluster edit permissions to be able to deploy my app and such in my cluster. And we'll see the output in this slide. I have the ID as AWS and it's installing the runner. It uses Helm under the hood. and then adopts the runner. Alrighty, let's get into it. So before I start, I will show you the Waypoint UI, where you can see I do not have any projects, but I can create some. So let's go ahead and do that. So here's my README for my repo. I had a few prerequisites, install the AWS CLI, set your credentials, create the cluster, and then update your kube config accordingly. So let's look at some of the code. Here's my server.go, starting server on port 5300. It's registering my hello service. I have a hello.proto with a message request and a message response with my hello service here, which takes in the message request and returns the message response. And here's that hello.go say hello method. And then I did write a little client just with, insecure credentials here. And then this is my auto-generated protobuf file. Okie dokie. And let's look at the waypoint.hcl. So you can see here, I have a project HashiTalk deploy AWS. I have my hello app AWS. It's using my runner profile, Kubernetes AWS. And then I have what is very similar to the PowerPoint slides, a build, deploy, and release stanza in my app. And of course, with some more config. So I'm using Docker and just some extra config I have in here, a variable image, which all the variables are defined below. I have my image, username, and password, which is grabbed from an environment variable. And I'm using a getref pretty for the tag, which returns the humanized version of the git hash. I ran into an issue later on that I'll discuss. That is why I chose to use getref pretty. And then I'm, setting credentials for authentication to push to the Docker registry. So username and password, and then deploy and release. Nothing too spectacular there. Let us go back to my handy dandy instructions. So, okay, let's take a look at my terminal. I have my runner install command here, the runner profile set with an environment variable as my Docker password, which I will not show, but you can see here, I have my kube config set with my AWS context. You'll see I have an alias set for K being kubectl, so bear that in mind. And I actually have a few Git aliases as well. But here's my runner pod up and running. And if I show you the role bindings, we'll see I have a runner role binding and an on-demand runner role binding such that they have cluster edit access to my cluster, and then the appropriate service account per runner and on-demand runner. This is my Waypoint runner list. I did create all of my runners in each cloud provider ahead of time. So here's my AWS one. It's of type remote. Here's my GCP and Azure, each with the different label. And then the runner profile list shows you that I have a corresponding runner profile per runner. So here's the AWS, GCP, and Azure that I reference in the HCL file with the appropriate runner target label here. I have my HCL file, I have my app, I have my kube context set. So let's go ahead and run a Waypoint init. So you see my project was initialized. If I do a git status, I don't have anything else to commit. So let's go ahead and update our project. After running the init, I can see my project there. So if I waypoint, if I inspect that project, you'll see I have my data set or my data source set to local. So I actually want to change that to reference my GitHub changes. So it's a project apply. It sets the data source to Git, sets the branch and a few other things such that if I run this inspect again, you can see my Git URL, my Git ref, and the data source set. So remote is enabled now. So now that we have all of that, let's run a waypoint up. And you can see that it's cloning the data from Git using the information from the data source, has the URL, the branch, the Git commit, timestamp, and my lovely message tweaks to README. And it's building the app very similar to how it looked from my PowerPoint slide. And we'll just give this a few seconds to, do its thing. Great. It looks like it all went through. So if I scroll back up, you can see my build. The image was pushed. It's deploying my Hello app AWS and then releasing it. And so now if I run k-git pods, ignoring the tasks, you can see a app created in this pod. So if I k-logs that, through all of this, you can see starting server on port 5300. That looks familiar. Everything worked just fine. All I had to run was a waypoint up. So let's get back to the UI where I can showcase that from in here. You can see this is my Cassie Coil org, and I'm looking at my HashiTalk deploy AWS project, which has one application, HashiTalk deploy AWS, with my deployment that's available and deployed. And then clicking on the deployment, you can see more information on it, build, deploy, release 1 minute ago, some operation logs, and resources. Super helpful and very clean to look at. Let's get back to the slides. Okay, so it's been a few months from my successful deployment, and I get an email saying that there's been a mandatory cutting of costs, and I'm to deploy my app to GCP GKE. And in my brief use of Waypoint, I know that I already have an app, I already have my HCL file, but I just need to tweak a few names and deploy my app to GCP. So it'd be the project name, the app name, and then switching my cube context. And disclaimer, I am by no means advocating for switching to GCP GKE to cut costs. This is a hypothetical reason for a hypothetical scenario. Again, you'll see I did a runner install into this cluster with the ID, GCP, and a corresponding label. Alrighty, let's get into the demo. Deploying my app to GCP GKE. So let's check out the README. Of course, there's some prerequisites. I had to install the gcloud CLI and create the cluster. And then we'll have to update my kube config. So let's just go ahead and do that now. Using my recursive search to use my GCP context. Great. Now if I k-git pods, I can show you that I just have my one runner running in my cluster. Okay. Let's go ahead and configure Waypoint. So I already showed you my runner with the corresponding runner profile already there. We switched our kube context. So let's make those changes to the waypoint.hcl file. Again, I'm going to leave all of my app, like server code and whatnot, the same. I'm not going to change that whatsoever, but I do actually want to use GCP instead. So we'll just update to use my GCP runner profile, this one here. You can see GCP, and then I want my app and project to have GCP in it. And that's all. I'm going to do all the same steps, except, you know, push those changes. So let's go ahead and do that. Here's my alias for git status. You can see the git diff. I just changed the name. So git add. We'll use GCP and then push. Great. Now that my code is pushed up, let's run a waypoint init. So now if I run a waypoint project list, we'll see I have a GCP project here. And again, I do want to do the same project apply just on my GCP project. So we'll go ahead and do that. My project is updated. So waypoint project inspect this project name. And it's all the same stuff with my git URL and ref. Okay. Now that that is done, let's run a waypoint up. And I'll give this a few minutes to go ahead and run in the background. So we can see here, I have two projects, a HashiTalk deploy AWS and a HashiTalk deploy GCP with a hello app GCP. And it hasn't gotten to my deployments quite yet. Great. Now you can see the up was successful. You can see here my waypoint up operation was queued, waiting for job and waiting for runner assignment, cloning data from Git using the new commit message that I typed in. It's building the app, it's deploying the app and releasing my app such that if I run git cods, you can see that I have another successful app deployed. And if I come over to the UI, then of course you can see more operation logs and such. Alrighty, so our second app was deployed to our second cloud. Let's get back and get into deploying into our third cloud. Alrighty, so it's been a few months. I get an email and I read that my CEO really likes the Azure stack. And, you know, we just acquired a new company that uses Azure quite a bit more than our current company. And since our CEO likes it so much, he wants there to be more cohesion between our companies. And now I'm told to deploy my app to Azure AKS. And by now, I'm a more seasoned Waypoint user. You know, I want to test out some more features. I realized that I want to do more than what like Waypoint Up provides for me, more than a build, deploy, release cycle. And I'm feeling more confident in myself and using Waypoint. I think I want to get a Slack notification if my app is deployed successfully. So let's go ahead and do that. You know, I did some Googling and came across pipelines. It is a newer feature on Waypoint, and it expands the build, deploy, release operations. So if you think about what about testing after a build or running security scans? Using pipelines, I'm able to tell Waypoint what order to run operations. So for example, Here is using pipelines to simulate Waypoint up. So we have project my project. You have pipeline full up with 3 steps: my build, my deploy, and my release, which each use the build, deploy, and release stanzas in my app. So pipelines is more configurable, and this is just a simple example of it. So let's expand that. Of course, I have another runner install, this time with the ID of Azure and into my Azure cluster. Let's get into that demo. So we'll pull up my handy dandy instructions, some prereqs. I did do an Azure login after installing the Azure CLI. You get credentials for your cluster and set the kube config. And then the same steps. I already ran the runner install, did the runner profile set with my environment variable, and then we'll make changes. Let's go ahead and do that. So let's use my new cluster context, which is the Azure context, using my recursive search. Great, I am set to use my Azure cluster. Let's go ahead and add pipelines into our waypoint.hcl file. Actually, before I add it, I'm going to, of course, update the project name, the app name, and my runner profile. Great, that says Azure. And now let's add in pipelines. So I have a pipeline here, deploy and notify, with 3 steps again: my build, which uses the build stanza, my deploy, which uses my deploy stanza, and a notify Slack step, which uses the exec plugin. So it's doing a curl against http stat.us/200, but imagine this is hitting Slack and not http stat.us, okay? Everything else will remain the same. We'll save that. Go back to my instructions. Okay, we'll add that. So git status, we will, well, I can do a git diff. So you'll see I just changed the names there and then added in the pipeline stanza. So let's git add, git commit, adding pipelines to Azure. Great. Oops, git push. Great, now that that's already pushed, let's go ahead and run a waypoint init. Great, projects initialized, my config file appears valid. And let us do the project apply again using my Azure project. So if I run a waypoint project list, you can see my 3 projects. And the project apply was again successful. And so this time I don't want to use waypoint up. I want to use waypoint pipeline run with my pipeline name. And I'm going to give that a few seconds to run as well. Great. Looks like my pipeline run was successful. 3 out of 3 steps successfully completed on my deploy and notify pipeline. So you can see here's some of the output. It was starting to run, cloning from Git. Then you can see here the build and then the deploy. And the run was complete. It was referencing my latest commit and everything was successful. If I pull up the UI, you can see that I have my Azure project with my Azure app that was successfully deployed here. And some, operation logs and so forth. Alrighty, so now that that's complete, we have successfully deployed to all of our cloud providers. Let's get back to these slides. And now that we have, gone through all of our demos, I will discuss our learnings. So a big thing that I learned was that Waypoint does assume that your infrastructure is set up. So it is super easy to use Waypoint. I showcased that, switching just a few letters to switch, and my cube context to deploying to a new cloud provider. And you might have a platform team to provision the infrastructure for you. In my case, I didn't. I had to create the 3 sandboxes and the 3 different cloud providers, along with the 3 clusters, which wasn't as straightforward for each cloud provider as I was hoping it would be. So keep that in mind. On another note, something else I ran into was with Kubernetes caching. So when I was incrementally tweaking my app and whatnot, I was running Waypoint up, which would build my app through Kaneko. It would produce the Docker image and push it and then deploy my app. But then Kubernetes was seeing the same image name and the same image tag and then was using a cached version. So my pod was running, but never ready, and it was listening on an old port. And that was not the easiest to figure out, but that is why I used the git ref pretty. Hopefully you enjoyed hearing about and seeing some of the capabilities that Waypoint provides through my demos. I encourage you to check it out for your own use cases. Thank you for your time. Enjoy the rest of HashiTalks Deploy.
Absolute killer. I think Cassie makes a ton of really good points in there. My favorite ones were definitely that there is never a standard way to deploy between different app tools. You always have to figure it out and come up with a solution that makes sense for your team. I loved seeing how this workflow works out for the 3 major cloud providers. And I know you can make this work for others as well. So check out the repository. We'll share a link for that in the chat, and make sure you get a chance to play with it. And I think one thing that gets really clear in the demo here is that Cassie clearly lives in a command line, right? Aliases for pretty much most operations. And I think for future HashiTalks, we're just going to make it a requirement that speakers not just share their demo code, but also their shell environment. Because let's be honest, I want to see all the aliases you have and save myself some time. For now, we're going to keep things slightly different. We're going to keep them secret with our next speaker, Jubril.
All right. Hello, everyone, and welcome to my session entitled Keeping Things Secret. Well, before I proceed, I'd like to mention that managing secrets is hard, and shout out to anyone managing secrets in production. Also, I'd like to thank the organizers for this opportunity. Thank you so much. So, who am I? I'm Jibril Yetunji, a software engineer and a third-year student of cybersecurity. You can find me on GitHub or on Twitter at syntaxerror, and when I'm not coding, I'm probably playing video games or drinking coffee. First off, I'd like to talk about some of the challenges with secret management on Kubernetes. These are largely based off my experiences and also some of my observations from other people managing secrets. The first and probably the most obvious is that there's no encryption at rest, or probably any encryption at all. So, this poses a challenge because if your credentials or secrets get compromised, you're in deep trouble. Also, this is tied to my next point, which is committing encoder secrets into Git is all too easy. When you have a manifest and with some secrets in it, most times it's not encrypted, it's encoded. And if you're like me and you tend to forget things a lot, well, you're in deep trouble if you commit this in, if this makes its way into Git. This leaves you vulnerable, or just leaves your credentials exposed in general. The third would be our back for secrets. While you could argue that RBAC exists for secrets as RBAC covers API resources, I'd say it's not geared towards secrets, and secrets just happen to be an API resource. So where do we look? We look to the vault, not this vault, but HashiTalks vault. So how can Vault help you with secrets? Well, a few ways. The first is encryption at rest, which tackles my first problem out of the box. Vault helps you, or Vault encrypts your credentials so that they are safe, even when they are compromised. But they shouldn't get compromised in the first place. Next would be access control out of the box. Vault provides a powerful means for doing access control management, which is really nice. The third would be third-party integration. Vault allows you to use third parties to do identity management. So if you're an AWS, Azure, or if you're using GitHub as an identity provider, Vault provides you a way to integrate this. The third would be dynamic secrets. Vault also provides you a way to dynamically generate credentials, and it can also manage them for you as well. Leasing and renewal is another big one I hear people say. So, while personally, I haven't really used this. It's a feature in case this is something you're looking out for. The final one would be injection, which is what I'll be demoing today. Vault allows you to inject secrets directly from Vault into your running application, which is really powerful if you don't like rewriting your whole application just to be able to use Vault. So, it's demo time. To save some time, I'd be walking you through a pre-recorded demo of me running Vault and injecting secrets into an application I've built. So first off, I have deployed Vault into my cluster, and it's running, and it's also unsealed. The cluster I'm using in this case is Minikube. All right, so first off, I'm just going to be showing you what I have. If I do a kubectl get pod, you see I have one instance of Vault. This is because I'm running Vault in standalone mode, as well as the injector, which is essential for the next part, or later in this demo. So next, I'm going to enable Kubernetes auth. As you can see, I have already done it because it says here that the path is already in use. So Kubernetes auth enables Vault to be able to communicate with Kubernetes and do what Vault needs to do. But before I proceed, I would actually need to exec into one of the Vault pods to provide Kubernetes with the auth config, which is basically token, reviewer, JWT, and the Kubernetes host information. First, I'll need to log in, and I'm going to be grabbing my root token from down here. Again, my default is unsealed, so I stored my keys in the directory. So once I grab that, I'm able to log in, and next I can just write the Kubernetes auth config. To save time as well, I have already written out the command, also because I tend to forget it a lot. So yeah, once that's done, I can exit out of the pod and show you the cluster role binding. Basically, this is to provide Vault with a service account and give that service account a cluster role binding. In this case, it's system auth delegator. This is because Vault needs some elevated privileges to function. Once that's done, I can apply this to my cluster. Because I've done this already, the resources are changed. Next is the policy. Basically, a policy allows you to tell Vault what a particular app or role is allowed to do. In this case, the capabilities are read and list, and that would be for the path apps data guardian. Guardian is the name of the app I will be deploying, so I place it under the path apps data guardian. Once it's done, I can use the Vault CLI to write this to Vault, and that should get uploaded. All right. Next, you'd want to create a role for the Guardian app. So in this case, I'm placing down the path auth Kubernetes role Guardian. The field bound service account names basically tells Vault what service account is going to be operating under the role Guardian. In this case, I've named it Guardian SA, and the service account namespaces this role will be bound to is the default namespace. Also, if you remember the policy I deployed earlier, it's called Guardian RO. So I'm specifying that here, and the TTL of 24 hours. Once that's done, you can write this to Vault. And now I'll be showing you the manifest. Like I mentioned, the name of the app I'll be deploying is Guardian, and Guardian is a very secure app which shows you credentials that it has in Vault or it has obtained from Vault. This is because it's looking for a specific text file that Vault would inject into the pod, and so it's able to pick up credentials from there. And remember the service account I mentioned earlier, it's defined down here as Guardian SA. All right, so you can apply that and the app gets created. I'm going to port forward the app so I can access it from localhost. Okay, all right. So at this point, if you try to curl the secrets endpoint, the app is going to tell you that it holds no secrets. This is because the text file in which it looks for secrets is not available to it. Therefore, secrets cannot be found. So to solve this, you would first need to enable the Vault key value store, which is what I'd be using to pass in secrets into Vault. And the path I'd be using is apps, and I'm using version 2 of the Vault key value store. Once again, I have enabled this in some earlier testing, so it says the path is already in use. Next, I'm going to be writing a message to the app, which is the Guardian message and Guardian encryption key. These are just arbitrary values that I can switch around. So I would proceed to write this as well, and I get some information back. And now I'll be updating the manifest with a few different things. So first is the annotations. This is probably the most important part. First, I'm enabling Vault Agent Inject. The way Vault injects secrets into your application is by running a sidecar in the same pod, and this pod will be able to pass the secrets from Vault into your application. Next, I'm telling Vault what role this app is going to be using, and in this case, it's the Guardian role we created earlier. And I'm telling Vault to look under Apps Data Guardian for the secrets. If you remember, I put this in key value store earlier, so that's the path that Vault will look for secrets in. And here's the really cool part. This template annotation allows you to specify the format in which you want your secrets to look. In this case, I'm using basically a column to separate the individual values. So that's what you get here. Besides that, nothing really changed. The service account and service stays the same. So once you're done, you can easily write this out and apply it. So the only thing that gets changed is the app itself. At this point, if you try to call a secret endpoint, it says there's an empty reply. This is because Vault would actually have to restart. Would have to inject the pod, which would lead to a restart. So now I'm going to port forward the service again, and if you look at the output, it says Guardian has already found some secrets for us, and it prints them out here. So that's it for the demo. So thank you so much for attending my talk. I hope I've been able to show you some of the powerful features that Vault provides. In this case, it's just the application secret injection, which is something I found really useful, because if your application is trying to look for secrets and you don't need to make Vault aware of anything. Your application doesn't need to be aware of the secrets or the existence of Vault. All it knows is where to look for the secrets, and Vault just handles the rest. Once again, thank you very much for attending my talk, and thank you to the organizers for having me.
That was very insightful. I like talks that help us figure out new ways to secure our things, take us through the basics of everything. Very nice demo. And I'm also glad that we're able to attract speakers from literally everywhere, sharing their stories and their learnings with our tools. Next one up is Eddie, who's going to talk about one repo to rule them all. Love the reference here. And over to you, Eddie.
Hello, people of HashiTalks. Welcome to this presentation on GitOps, one repo to rule them all. Today, we'll be using a single source of truth for creating, managing, and maintaining all of your infrastructure and application systems. This is a really cool topic that I'm excited to talk about. Why is this so cool? Well, we're going to cover some declarative full stack information, some deployment pipelines, and some drift management methodologies from a single GitHub repository. We're going to talk about some context of what GitOps is with this scenario. We're going to do some comparing and contrasting of different IT operations models, some of the tools involved with GitOps, give a little demo context, and then we're going to hop into a demo and tie it all together and see it in action. So let's get started. Who am I? My name is Eddie Rowe. I'm excited to be here. I am the lead console education engineer here at HashiCorp. What do we do as education engineers? We essentially create content like this for the public to consume, practitioners to ingest and use and help build models for their productions or other uses out in the world. We do stuff like this. We do technical writing. We do the tutorials. We have a lot of content out there with the goal of serving you. You can also find me at this LinkedIn right here. I'll put this at the end as well. If you have any questions throughout this whole presentation, feel free to send them my way or put them in YouTube chat down below. So I really like Lord of the Rings, and you're probably going to be able to tell by the end of this presentation. Let's go ahead and check out our overview. We are going to navigate this subject with this map right here. The lands are treacherous as they are laden with terminology like zero trust, infrastructure as code, and feedback loops. So we're going to use this map to get us through these treacherous lands. Every story has a beginning, so let's start there. To compare these ops models, we're going to start by defining what they have in common, and then talk about the differences between ops, DevOps, and GitOps. So these are some of the general actions in the form of verbs right here that organizations perform to deliver IT services to their service consumers, be that machine or human or dwarf. You've probably seen these verbs before in that infinity symbol CI/CD diagram. If you've Googled that, it's very common. The difference between traditional ops versus DevOps versus the GitOps models is in the how and the who of these verbs right here. So how do different organizations perform the actions necessary to implement, manage, and deliver their IT services to service consumers? And that's primarily what's going to make the difference between these models. So let's dive in. And let's start by taking a look at the traditional ops model. This is the who and the how of the traditional ops model. And big asterisk before we dive into some of the details. Every organization is different, and this is a generalization for the purpose of doing some comparing and contrasting between these models. So with that said, in order to perform their roles, traditional ops environments may have roles such as project managers or managers, developers, QA, and operations and support, who use variants of the tools of the icons that we've listed here. Each role perform their duties with their tools and track the details in change management software, and they may track it in a wiki as well. In fact, these may be the main shared connection points between these teams, leading to individual teams working mostly in silos or specialized units. So if you've ever been in a place where a change management ticket was held onto it for a while by a networking team before one of the team members implemented that change, you may know this style of place and be familiar with this kind of workflow. Some of them are certain government entities or private organizations that operate in a legacy model. Now, the challenges of this kind of environment is a big one here is imperative state. I want to touch on that for a second. Imperative state is when you say how you get what you want, maybe in the form of a wiki with a lot of screenshots where you click through to get the desired income. as opposed to a declarative state. And a declarative state is what you say when you say what you want exactly. And this may be in the form of a configuration file that defines all the attributes to achieve the desired outcome. Now, some more traditional ops challenges this model is it can be overly complex with a lot of different systems, difficult to audit. A big one is the plan to release cycles take a long time, perhaps for reasons like the change management example we brought up in the previous slide. These models with imperative style operations are subject to human error and delays, and they require duplicate effort across various systems. Now, the DevOps model addresses many of the traditional ops model challenges by streamlining their roles and tools. This increase in collaboration also increases work efficiency and speeds up time to release. So in order to perform these duties, the DevOps environments may utilize roles like release managers, developers, automation architects, and operations and support, who may use variations of the tools listed here. What you may notice in this type of environment are more connected aspects of the CI/CD process across roles, as well as more shared tooling between these roles. And if you've ever worked somewhere where you've had to upgrade a Splunk ecosystem or plan configuration management update or server patching updates across your fleet, you may know this kind of place. Many modern organizations that work in this kind of model. Now, the challenges of this DevOps environment is that there's a lot of complexity to it. There's many distributed systems and a lot of tools. Each may require a certain update cycle or maintenance that's unique to those tools. The environment can also be difficult to audit. The maintenance of individual systems can be cumbersome, and they may have an imperative state or a mixed state between imperative and declarative models here. And there's still that very noticeable split between dev, sec, and ops. More touch points, but there is room for improvement there. This brings us to GitOps, the who and the how of this. Depending on the size and design of the organization, GitOps-style environments may have roles like release managers or project managers, developers, and SREs and support. A key differentiator that we'll see here is the utilization of GitHub as the primary connection point for facilitating the plan to release cycle. While each role still has its own processes, technologies, and duties, each of their respective orgs may utilize individual repositories or components of a repository as a single source of truth for the respective systems. The GitOps model is common amongst cloud-native organizations as they work by utilizing GitHub integrations with tools like Kubernetes, Terraform, and other CI/CD supporting systems like Argo and Flux. Due to the various integrations and automation, deployments become more consistent and require less manual work. So this may sound like the ideal state, but the life of one dwelling in Middle Earth is not free from stress and worry. These are some of the challenges that the GitOps methodology faces. Setup takes careful time and planning. Moving from the imperative model to a declarative model takes heavy consideration. And the more legacy systems and services that an organization or one has to move over to this model, it does take time and will increase time the more you have. The required technologies in use here require training and a different mindset. If anyone knows, coming from the VM world to the Kubernetes world, it is an adaptation and can feel cumbersome to begin with. The automation pipelines are still subject to human error, just like anything is. The pipelines here are just as good as the implementation of the pipelines. So with this being said, why is the effort even worth it? Well, we're going to show you. Understanding these benefits and efficiencies is what drives our customers to strive for this type of model for creating, managing, and maintaining their IT systems. A big one here, one workflow on one code base means faster iterative changes. It's also much simpler to audit in this kind of environment. It's all in GitHub and in PRs. The declarative state improves stability and resilience. So what you see is what you get. And then the rollbacks are easy too. So there's a built-in form of disaster recovery and planning. It's in many cases as simple as reverting a PR to revert to your previous system state. So in the next section, we're going to dive into how these benefits can be realized. But the main point of these comparisons is to show how GitOps is an evolutionary step in CI/CD, primarily due to its resource management capabilities and feedback loops. And just like Gandalf the White is still Gandalf the Grey at the core, GitOps is still a CI/CD methodology at the core, just with way more skills and powers. Okay, so hopefully we've given some more insight into how GitOps differs and resembles other IT operations models. The zoomed out view that we just covered helps understand the what and the why of GitOps. Now let's dive deeper into the how of GitOps. And getting started with a net new GitOps workflow is easy and almost free. In this example that we'll cover, the only cost for the core features involved here is a domain name. So let's talk about the main elements of how GitOps works. It's essentially a 3-step workflow. You code something into a GitHub repository. The integrated tools perform CI/CD and state sync, and then the deployment occurs as a result of that CI/CD and state sync. So as far as the workflow goes, there's many similarities with the DevOps model, but a few key distinguishing differences. The CI/CD mechanism takes declarative philosophy very seriously for the state sync. Once you go declarative, you never go back once you realize those efficiencies. It's one repo for everything. So this is your deployments and updates, your audit logging, your rollbacks, your infrastructure, your apps, and your security and compliance configurations in one location. And then another key differentiator here is these integrations like Flux and Terraform Cloud that perform that CI/CD and state sync and make it so according to your repo. GitOps workflows really shine in the cloud-native microservices and Kubernetes world, but they can also be utilized for on-premise and hybrid systems just as easily. I think the Tripwire CTO, his name is Gene Kim, describes the subtle difference between DevOps and GitOps really well in his book, The Phoenix Project. He says the second way is about creating right-to-left feedback loops. And in many cases, those right-to-left feedback loops involve the utilization of Terraform Cloud, drift detection, and Flux or Argo state sync. It's your actual deployment continuously being compared to your repo source code, asking, is this how it should be? Is this how it should be? Is this how it should be? And then ensuring that it's exactly in that state. Coupling this workflow that we see here on the slides with storing all the code that describes our system in a versioned manner, applying them automatically through that well-defined process, and then finally using a self-healing system is what we call GitOps. So let's cover the elements of a simple GitOps workflow in a little more detail here. First bit that we mentioned on the previous slide, coding. So the process that we're going to do in our example 2 is GitHub is the center point of this universe and interaction point for all humans. You create a pull request. You or someone else may review the pull request, and then the pull request gets merged. As a result of that merging, the CI/CD and state sync take effect here. In our case, we're going to use Flux and Terraform Cloud, and these are responding to those state changes in the GitHub code repository that you just made changes to. Finally, our deployment occurs. As a result of that, infrastructure resources are created as of 3. Now that you've seen the what, the why, and the how of GitOps, let's dive into a demo to see it in action. So let's deploy something. I want to level up my zero trust security profile with identity-based access. So I want to deploy Vault in my environment and start setting up Vault. And again, this is how we're going to do it. We're going to create a pull request, review the changes, and merge that request. So let's check it out. All right, so we have hopped on over to the pull request here inside of GitHub. And let's take a look at some of the changes that we're proposing in this pull request. First, we just have a small Vault addition to the customization file for configuration management. The real meat of this is in this Helm release file. And it has all the contents that you would normally have with a Vault Helm release file within here, with the caveats of some of these Flux system and Flux attributes here. And this is what enables Flux to manage the Helm release, both the initial creation and the management of it, and updating throughout its life cycle. The next file that we have is another configuration management file within that same directory. And then finally, this bit right here is a service definition file that in this repository, what it does is any services that are listed here, when Terraform Cloud looks through this and sees any changes, it's going to ensure that everything in this service list is going to have an associated DNS resource created for it in Cloudflare, as well as the Cloudflare Zero Trust resources. Okay, so this looks good to me. I'm going to go ahead and merge this pull request to our main branch. Good job, me, for writing this pull request. All right, back in our presentation. So as a quick reminder, these are the steps that we just performed. We created the PR, reviewed it, and merged it. Now, what happens as a result? So it's time to open a ticket to the operations team to deploy it, right? And then to the networking team for the SSL certs ports. Now, this is where the GitOps auto magic kicks in. Since Flux is watching your GitHub repository, it will deploy the Vault service and other resources from the annotations defined in the Helm chart, in this case, an SSL cert and an ingress route, into your Kubernetes cluster. Terraform Cloud is also continuously watching your repository and will deploy Cloudflare DNS resources and Zero Trust resources for your Vault service. As an added bonus, Renovate Bot continuously monitors your Vault Helm chart for updates and will automatically generate PRs with updated things like images or Helm chart versions for you to review and merge if you so desire. This drastically speeds up and simplifies updating across your service. And with test dev cluster instances, you can easily test these new versions out before implementing the changes into your prod cluster. And this is just a simple example to illustrate the core GitOps workflow. This is all highly customizable and extendable in any direction, depending on your intentions and or your requirements. For example, you could add annotations or additional GitHub actions to integrate Vault into your own observability suite or testing suite. It's really all up to you how you choose to design your pipeline and which systems you'd like to incorporate. So let's check our work. Did our workflow that we just performed, that PR merge, give us the intended result? So let's check it in 3 spots. We're going to check it on the Kubernetes cluster itself in the terminal, in Terraform Cloud in the browser, and then finally, we're going to check if our new Vault service is publicly available in the browser as well. As a bonus, we're going to check out our repos pull request tab in GitHub to see briefly how Renovate Bot works and some of the PRs that it generates for updates. And just a cool part of using this methodology, let's say you merge any of the PRs, for instance, like Vault, we just merged that one. It doesn't work as intended, it causes problems. Totally fine. Revert your PR change and the deployment goes away without any estranged resources or partial cleanups is a very important part of that. So let's hop into the second part of our demo and check our work. All right, the first place that I want to check it is the terminal. This is the previous run of kubectl get pods right here. You can see that Vault is not present. So let's give it a run now. All right, after merging our PR, you can see that Vault pods have been up for about 2 minutes. You may notice that 0 out of 1 state. This is normal for Vault at this point right here. Vault is a security program and it starts up relatively secure, as you may expect. So this requires a little bit of bootstrapping before it'll say 1 out of 1, but it'll still be publicly accessible. So we'll still be able to run our tests here. Okay, so we've merged a PR. Let's hop over to Terraform Cloud and see what Terraform Cloud looks like. I'm going to refresh the page to make sure we have the latest and greatest. And here we can see the latest run that's triggered here. You can see that Terraform Cloud responded to our PR change, or our merge from this PR, the Vault service PR, to our main branch. And it already applied it. You could also set up Terraform Cloud to just run the plan operation here, which will stage the changes, say what changes to be made, if you'd like to add a manual checking step here. But for the sake of automation, because we trust the thoroughness of the PR that went through and it was merged, we have it automatically sent through and deploy the Terraform resources. Now, what did it deploy? If you see the plus signs over here, you can see that DNS record was deployed to Cloudflare, a special administrator policy for Vault, and then some more zero trust resources for Vault were all created in Cloudflare. And we didn't have to go log into Cloudflare or click anything. All right, now let's see if this thing is actually accessible. We have all the resources in the cluster and outside of the cluster. Let's go to Vault, and then my domain name is openenergyproject.org. Feel free to go there too. See if you can hack into it. No, just don't do that, please. Although I doubt you can get in. So yeah, here we are. We are seeing Vault publicly. Right here, all the operation worked. We have a full public deployment that's working totally fine. We're able to access our Kubernetes cluster resources from those Cloudflare DNS entries. So awesome. All right. And so there it is. We checked all our work. Everything worked as expected. And that is a GitOps workflow. So alas, we have reached the end of our journey. My hope is that you can take something from this to benefit yourself, your coworkers, or your organization. As the technology landscape continues to change, it's always useful to try out something new to see what works for you. There's no perfect prescription for a system out there, no perfect recipe. What works best for you is unique to your environment, your limitations, your constraints, and your intentions. An important caveat that I'd like to call out is this was a home lab-based workflow. There are a lot of enterprise considerations. Big one is test dev branches and not committing directly to main and checking deployments. So definitely consider that in your practices. As Tolkien said, elves seldom give unguarded advice, for advice is a dangerous gift. Even from the wise to the wise, all courses may run ill. So yeah, there's no perfect prescription for a system. All right, that is GitOps, one repo to rule them all. Thank you all so much for your time and attention. I had a great time doing this. Put up my email address and my LinkedIn here, as well as the repository if you'd like to try this out. If you have any questions, please feel free to ask them in chat as well, or send me any kind of communication, any of these mediums here. Hope you have a great rest of your day. Enjoy the rest of HashiTalks, and see you next time.
Definitely enjoying talks like this. Everything worked as expected is personally my favorite outcome for any deployment. And yes, advice should always be taken into consideration, but obviously make it work for your team. So if you joined us early enough to follow along with Jubril's talk, you may not find yourself in the situation our next speaker, Dwayne, is going to describe, but you should stick around still, because one day you'll find yourself in a situation that goes like this. My credentials have been leaked. Now what?
Hey everybody, welcome to my talk. So my credentials have been leaked. Now what? Here at HashiTalk Deploy 2022. I'm Dwayne, I live in Chicago. You can find me out on Twitter at MCDwayne, and I'm happy to talk to you about anything we're talking about today, or anything you want to chat about. I work for GitGuardian. We are a platform helping people find and mitigate their secret leakage, as well as do validity checks for other things that they're deploying out there. I'll talk more about them in a little bit because I do reference one of our piece of research later in talk, so we'll move on. So very simply don't let your credentials leak and you'll be fine. But that's not reality. Reality is that we all deal with secrets and credentials all the time. I'm going to use those terms interchangeably. When I say secrets, I mean credentials. When I say credentials, I mean secret credentials. We're in this constant game of cat and mouse with malicious attackers who want our data, who want our compute resources to do all sorts of malicious things, and they want our information. The most likely place they're going to attack is the place where they can get the most access and do the most damage. If you're an individual user of a system, please update your passwords regularly, use strong ones, and use two-factor authentication. Same for the business. Make sure that where you're putting your secrets are actually secret places. Use password managers, please. And always enable MFA when sensitive data is at play. Remember that and you'll be fine. For everybody else, or for the DevOps organization, everyone else on the slide, for the DevOps organization, we need to worry about a lot of things. The API keys, our username password pairs for system logins, browser certificate tokens, certificates. There are so many things we need to take care of. EMV and PEM files. It's a growing problem. We wish it wasn't, but here's just a few examples from 2022 and just the last few months. Uber, a teenager got in through a phishing attempt, found PowerShell scripts that had hard-coded credentials, and then laterally moved through the system, pwning everything, even their Slack instance. Toyota had a subcontractor who accidentally pushed part of a repo publicly that contained a key to a data server that had 296,000 customers in it. It was public for 5 years before they figured it out. AstraZeneca, they leaked a secret to a test environment, which on the surface doesn't sound that big of a deal. It's a test environment. What could go wrong? Well, someone else had actually put real patient data, real customer data into that test environment. So we don't know exactly how much was exposed, but we do know it was exposed for over a year. There's a lot more stories like that, so much so that they actually fall into number 2 on the OWASP top 10 types of attacks. Fall under use of hard-coded passwords, CWE 327 here. This moved up a spot from 2020. This problem's only getting worse. This is something we corroborated in 2022 State of GitHub's State of Secret Sprawl on GitHub. You can go read that report from us at Guardian. We found 6 million secrets just laying out there in public GitHub repos. This is a major increase over the previous report that we did, and we saw, on average, 50% increase in the number of secrets per commits. It's a growing problem. So everybody agrees, don't do this. This is a bad idea. But we keep doing this. And I think it's not malicious. I think sometimes you just got to test if the API is working. It just, is the database credential correct? This is a quick way to do that. The problem isn't that we do that. The problem isn't that we forget to take it back out and then we commit that and we push that. Then you're going to have a bad time. So if you were sitting there and think, well, was I exposed? I think I was. Here's a quick guide. If you see plain text credentials in your code, configuration, or logs, assume everyone else on Earth can see them too. They should never be plain text in those places. Is your EMV or PEM files or other security files in a repo that can be accessed by you? That's not good. Those should be somewhere else, not in your version control. And do you know for sure who has access to the code? The best part about Git is that everyone has full access to the repos and they can collaborate wherever they are on Earth. The downside is that everyone has access to the repo and they can push it wherever they want, publicly or privately, inside your org or outside of your org. It's a double-edged sword with version control. But also, you might just get told that, hey, you've been breached. Uber, when he pwned, that teenager pwned their system, he went into Slack and told everyone, here's what I'm doing. They didn't believe him. So he went to the New York Times and said, hey, I pwned Uber and here's the proof. Hopefully you don't fall into that situation and you catch it early. But what should you do if you do get breached? That's why we're here at this talk. That's the heart of the matter. Breathe, validate what's going on, scope the impact, notify the impacted teams, report it, and then rotate those credentials. You might not agree with me on 100% on this order, and you might think, hey, you left some stuff out. Sure. But this is a starting point. I think these are the bare bones essentials that you need to do. And this is my preference in order. You might feel differently. But first, breathe. You're a human being before anything else. Being in a panic isn't helping anybody, no matter how bad the situation. Take a step back, breathe, recite the Bene Gesserit litany against fear from Dune, and calm yourself down. Act urgently and with purpose, but not in a panic. That's going to be the first step. Breathe. You're a person first. Validate. Is there a reason to worry here? What type of credential was it? Was it to a system that you even use anymore? Is it still an active key? How recent is this? Is this a key you rotated 2 years ago that somehow ended up public? Fine, that's something to deal with, but it's nothing you need to stop your day or sweat about. Is it going just to a test environment that properly uses sanitized data? Much less concerned than someone actually getting into your production environment. But just start validating these things and start making lists. This is a short list we use inside of GitGuardian. You can find this on our docs and in a blog post, but it's just a place to start. But validate that there is a reason to worry. Scope the impact. In DevOps, everything's interconnected. Everyone in the company is touching the pipeline somehow. Figure out what systems are actually impacted. If it's an S3 bucket that has business PDFs in it, that's one concern. If it is an access key to your AWS environment in total, that's another terrifying thing that you should be aware of. Once you've scoped, like, all right, I think all of these systems are impacted by this incident, notify those teams. You might disagree with me that you should report it first and then notify to give them something, but start the conversation as early as you can. Make contact. There's IRC, Slack, pick up the phone, go walk to their desk, whatever you can do. They're going to provide more information than you have and give you insights that you won't find on your own just sitting at your desk looking at your computer. Once you've got all of that done and you've got the information at hand, that's the time to report it. That's the time to sit down and write, here's what happened, here's the timeline, here's who was affected, here's my proof, and here's how bad I think the situation is. Again, you might disagree with me on what order. Your company probably already has a reporting form that they prefer. Use that one. If you're starting completely from scratch, this isn't a bad set of steps. Also, how you're going to remediate it is a very important part of that report. Then finally, the thing that your gut told you to do in the beginning, rotate those keys. They're like old-fashioned fuses, but like old-fashioned fuses, you pull one out, everything connected to that system goes down, and anything reliant on that system will also then go down. Have those conversations. Hey, who on your team actually is responsible for replacing those credentials? How do we replace those credentials? Is there automation for that? What happens if something breaks? What's our plan? I don't know the answer to those things. Your company will have to have those conversations internally. So how do you use all of that to prevent future attacks? Well, simple things. Use git ignore files. Stop hard coding secrets. Use things like env files that you then don't commit. Here you can see this is improperly used. We've actually commented out env files. Don't do that. Use HashiCorp Vault. It's awesome. It's the gold standard. If you're on Azure, I recommend Azure Key Vault as well. There are tools to help you. Azure Key Vault, HashiCorp Vault is awesome, and everyone should be using it. I'm not just saying that because I'm at Hashi Deploy. Use GitHooks. They are the best automation platform I can recommend. They're user-friendly because they're just scripts, and they're everywhere, and your developers already love Git. So there are 3 pre-commit hooks that you can hook into to look and see if a secret has been added to the code and will prevent that commit from happening. There's a pre-receive hook that says, before I take it onto the server, those changes onto the server, I will look for the secrets and then I'll reject them. You don't have to build this yourself. You can build this yourself, but AWS Labs has an option for this. Trufflehog has an option for this. And of course, we at GitGuardian have an option for this with GG Shield. Here's what ours looks like. You have a hard-coded secret. You try to commit it, and it says, hey, you can't do that because you have a secret here, and there's 2 instances of it. How do you prepare for future leaks? Because they're going to happen. That's just reality. Well, if you ask Google, it tells you this. This is the entire document in Google Help. Change your keys and redesign your app. It's true, but it's not super helpful. What I think you also need to do is organize your learnings. I think playbooks is the right methodology for that. Take what you've learned from the incident, those reports, and start looking through them. Take some time, set it aside. This isn't part of the incident. This is a retro. This is a larger, how do we better position ourselves with our security posture by having these remediation playbooks at hand. Playbooks can be this simple. If this happened, we do this. If this happens, do that. Just think about them as flowcharts or checklists, making it easy and thoughtless for someone to say, all right, this happened, I follow the dotted lines and we fix it. And then they don't panic, and then there's a lot less to worry about. Again, you can use all sorts of off-the-shelf checklists or things in those flowcharts to assure that you're in the right place. Those are ours. You can use it if you want. If you do build playbooks and they start getting complex and you start needing to log into multiple systems and pull up certain reports and fire off certain commands in certain orders, you can start automating that using notebooks. Turn playbooks into notebooks is a project. I'm just saying Jupyter is the standard out there for how notebooks work. I'm not saying go use Jupyter notebooks, but if you can't automate a thing, automate a thing. And notebooks aren't a bad way to do complex sets of repeatable steps. So in conclusion, you're not alone out there. We're all in this fight together. There are a lot of malicious actors after our data and tools. If an incident happens, you're human first. Breathe, calm down, focus on what needs to be done, and then go validate that there's a situation and how severe it is. Scope the impact throughout the DevOps organization, what systems are affected. Notify those teams and get their feedback as you're building all this information out. Finally, organize your findings into a formal report. As you're building that, start the remediation process and actually rotate those keys. Take those learnings out of your head and put them into things like playbooks, or at least docs somewhere, to know if this happens again, we know exactly what to do. I've been Dwayne. I live in Chicago. Hit me up on Twitter. I'm happy to talk to you about anything. This has been my talk, so my credentials have been leaked. Now what? Here at HashiTalks Deploy. And I'll be talking to you over in the chat for this event, but if you're watching this after the fact, hit me up on Twitter. I'm always happy to talk to people. Thanks.
Obviously, I can't disagree with Wayne when he says everyone should use HashiCorp Vault. Vault enables you to make friction-full security procedures a lot less annoying. And anytime security is not annoying, you actually end up using it. If Vault isn't in your future, that's okay. Figure out other ways to limit your exposure. Go through every part of your infrastructure. If you're using Terraform, make smaller state files. Split out resources. Don't touch all the resources all the time. Have separation of concerns. We've done this with CSS. Why are we not doing it with our infrastructure, right? With that, we've got a couple of comments that I want to briefly address. All the sessions you're seeing right now, you don't need to memorize fully because we'll be posting the videos online in a few days. So you can rewatch them or watch them for the first time. We've got the CFP for HashiTalks 2023 open. So if something today sparked an idea for you that you want to submit, head on over to sessionize.com/HashiTalks-2023. And we'll have a link for that up in the notes as well. And submit your talk. You have, I want to say, about 8 hours left. All it takes is 15 minutes to come up with a good proposal. And very excited. Yes, we will have events in 2023 in person. So hopefully we'll see some of you there. With that, we're going to head into a quick break and we'll be back in about 10 minutes. Welcome back, everyone. If you've been here for the first part of today, then you've enjoyed a couple of nice talks, strong focus on security. We called HashiTalks Deploy, but we all know that your deployment is going to be a real bad moment if you're leaking some security credentials, passwords, API keys, what have you. So to prevent that from happening, we've already shown you how to set up vault policies. We've shown how to deal with that moment when you actually leak, which, if we combine that with the first talk that Cassie gave of deploying to 3 cloud providers in the same go, of course, we're following best practices. So we're looking at least 6 accounts each. Yeah, it's a lot of passwords that we need to keep secure. So with that, I think we're going to kick it over to Jillian, who's going to take us through bootstrapping Terraform secrets with the 1Password CLI to avoid leaking secrets.
Hey everyone, thank you for joining my presentation on how to bootstrap Terraform secrets using the 1Password CLI. You probably already know about how 1Password can be used as your day-to-day password manager, but 1Password has also created developer tools that work to secure your development workflows. But before I move any further, let me introduce myself. My name is Jillian Morgan, and I'm a technical lead on the developer ecosystems team at 1Password. My team focuses on building tools that expand how 1Password can be used by developers. If any of you would like to get in touch with me after this presentation, my contact details are just on this slide. So for today's agenda, I'll give a quick overview of what Terraform is. I'll then talk about what problems you may run into regarding credentials needed by Terraform, and then I'll talk about how these problems can be solved using the 1Password CLI. And then lastly, I'll give a demo of my proposed solution. So first, I'd like to quickly go over what Terraform is for those who are new to the tool. Terraform is an infrastructure as code tool. So like the name implies, infrastructure as code refers to the managing of your infrastructure through code rather than a manual process. So Terraform allows you to describe your complete infrastructure in the form of code with the use of configuration files. The files define the resources for our infrastructure. So Terraform parses the code in these defined files and translates it into an API call, which is made to the resource provider in order to create and manage the desired resources. The Terraform files can be pushed up into source code where team members can then collaborate and review. And what's great about this is that these Terraform configuration files can be reused to speed up deployment of infrastructure resources, and it ensures a consistent workflow across environments. So, of course, when configuring infrastructure, you need a base set of credentials to access said infrastructure. But if we're making changes using our local machine, how can we get these credentials locally? Currently, most people use environment files with plain text passwords inside. But imagine this scenario. You've created a plain text environment file in order to make changes to your infrastructure using Terraform. And once done with your Terraform changes, you commit all files to source control. But oops, your git ignore was not configured to ignore your environment file filled with all these plain text secrets, and now they've been leaked to your repo. Now you have to spend your whole day re-rolling your credentials and potentially dealing with some unhappy team members. Now, another scenario I'd like you to imagine. You're making some changes to your infrastructure using Terraform. You go to apply the changes, but they fail. You talk with some of your coworkers, and they tell you that everything works for them on their machine. Typical, right? After some investigation, you learn that the credentials to access your resources have changed. And because you and your coworkers are working from multiple sources of truth, using these plain text passwords, environments are not consistent, and you must manually update secrets when a change is made. That is, even if you're aware the change is made. So how do we solve this? So the root of the problem in the scenarios we just discussed is that we're storing sensitive values on our machines. So let's remove them. With 1Password, we can store these credentials remotely and replace these secret values in our environment configuration with reference to where these secrets are stored in 1Password. The 1Password command line tool can then be used to load these secrets directly from 1Password into where we need them. So I'll quickly just show you what that looks like in code. In our environment file, instead of writing out our plain text credentials, we can replace it with a reference to where these secrets can be found in 1Password. So in my example here, I prepend the reference with op:// so that the 1Password CLI knows what content to replace. Development is the 1Password vault I want to access, and then the word database is the item I want to access. And then username and password are the fields I would like to assign to DB user and DB password variables respectively. So now that we've removed the secret values from our code, we can safely check in our environment file into source control so that everyone on our team can use the same credentials without risking this sensitive data. So that means no more worrying about whether or not you've added your environment files to gitignore. In fact, when using secret references, you should push up your environment files. And this is because with 1Password, we can share access to credentials with other members of our team. So anyone with access can use the same secret references to access the linked credentials. And then any changes made to these credentials will be made immediately available to everyone on your team, rather than manually updating secrets across all these different development environments. So when your teammate makes a change to the code base that requires a configuration update, they commit the required config changes in the environment file together with the code changes. These references can then be reviewed to make sure the correct secrets are being requested. Once approved and merged, all a developer needs to do is pull down these changes, and then they're good to go. So all the configuration is synchronized through source control, and you never have a broken environment due to incorrect creds again. So this ensures that the configuration is reproducible and complete, eliminating those, well, it worked on my machine comments. So this can greatly accelerate onboarding as well, as when new people join your team, they no longer need to spend all this time configuring their local environment in order to get started working. Instead, their manager can just give them access to the credentials that are needed for the project. And because we can now check our environment files into source code, developers can get the project up and running right away with no time spent determining what and where are the proper credentials. So since we are at HashiTalks, you're probably wondering, why not use Vault for this? Vault uses secret references as well, but we have a bit of a chicken and the egg problem here. Where do we store the credentials we need to access Vault? And furthermore, we already know about the benefits of writing infrastructure as code, so shouldn't we be configuring Vault using Terraform as well? So I'm going to go ahead now and give you all a demo of how this will work in practice. So let me just switch over to my desktop here. So for this demo, I'm going to use Terraform to create a simple VPC network resource on my GCP project. I've already gone ahead and created a Terraform file, configuration file for this here, but of course I'll need to include credentials in order to access GCP. So for supplying GCP credentials to Terraform, you can use an environment file that includes a variable for Google credentials. So normally in an environment, you might set the variables here as plain text credentials. That's what I have right now. But we can actually use 1Password secret references here. So in 1Password, I've already gone ahead and created a vault for my developer team that will need to access these credentials. So I have one here named devs. And then within this vault, I've created a 1Password item that holds my GCP credentials. So we have this item called GCP, and within that we have a field called credentials. So for my reference, first I need to make a marker here so that 1Password CLI knows which variables to fetch. So as mentioned earlier in this presentation, that was op://. Next, we need to specify the vault we want to access, which is devs. Then the item we want to access, which is GCP, and then the field we want to switch in here, which would be credentials. So I'll save that there. But as a side note, 1Password also has a VS Code extension that can automatically move your existing plain text secrets into 1Password and then replace the text with a reference that can be accessed later. I'd recommend you checking that feature out if you have the time, but for now, we'll just type it in manually. So now that my secret reference is set up, I can start running some commands in Terraform. So to have the secret references updated, we can prepend our Terraform command with op run. So let me just show you what that looks like. And then the environment variable the environment variable file we want to use, which is just .env here. And then 1Password will also ask us to just give us the command we want to use op run on, which is just going to be our Terraform apply command. So let me just run that. And you'll see here, 1Password is just asking for Touch ID to authorize access to fetching these credentials. So I'll just give a little touch there. We'll just say yes to get that going. You could also alias this command so that the op run command starts every time you just type in terraform apply rather than typing op run and handing in the environment variable. So now that we've run terraform apply, if we go back to our file, we can see that the environment file itself was never updated. So you can see this is still the secret reference here. We'll just go back. So with this new workflow, the environment file on your system never has the plain text secrets. Instead, the 1Password CLI passes the secrets to just the process running on your application, and the secrets are only kept in memory and never written to disk. So that adds to the security of this workflow. So if we look here, we can see that Terraform applied the changes using the secret references. So let's just go back to our presentation slide. So because there is such a hassle to rotate credentials and synchronize them across environments, developers would avoid rotating secrets in the past. And this new way of collaborating on the environment configuration removes the manual steps required to synchronize these changes. So now we can rotate credentials as many times as we'd like without interrupting the developers working with them. This is especially important to do for development workflows that connect to production infrastructure, which tend to be a little more sensitive. So now I'd just like to thank you all for coming to my presentation. If you have any interest learning more about the 1Password CLI and what other capabilities it can offer to help you with your development workflows, please take a look at the first link. But if you want to learn more about other development tools that 1Password offers, take a look at that second link there. And lastly, if you have any questions about what was shown in the presentation today or any of our other developer tools, feel free to join our Slack workspace. I've included the link on this slide. You may want to take a screenshot because it's a bit long and I don't expect you to remember all that. But I'd like to thank you all again and enjoy the rest of HashiTalks.
So many different workflows, all to make it just a lot simpler to not leak credentials and to not have long-running credentials. I like it. If you're a fan of the 1Password CLI and 1Password in general, definitely check out their shell plugin. It was released a couple hours ago, already has Vault integration, making yet one more hurdle go away. We shared a link for that in the chat. And yeah, with that, I think it's time to introduce our my co-MC, Pato. Hello.
Hello, Kareem. How's
Thank
it
you
going?
for joining us. It's going great.
Thank you. So, see, my dog wants to join too. Here he is.
Hello.
Little scruffy.
I like canine co-MCs. It is honestly my personal preference to always have an animal in the picture. But
yes,
so I'm curious, where are you joining us from today?
New York City. I think maybe the reason why you're asking is because you know that I was recently in Qatar for the World Cup, and I just came back 2 nights ago. It's an amazing experience. You can hear it in my voice a little bit, maybe. A lot of talking, yelling, walking, doing a lot of activities. It was an experience of a lifetime. And so actually, this is one of the souvenirs I brought. Is like the logo of the tournament. This one right here. So wanted to show that a little bit.
It is indeed what I was alluding to.
Yeah. But back home, back in the flow of things, back to work, back to creating digital things that we love, and that's what we're here for.
That is definitely
and more talking.
More talking.
Yes.
And giving your voice absolutely no rest.
I know. Should have said no to this and yes to the World Cup, of course. But here we are, giving over 100% all the time.
Well, 2 events that bring people together from all over the world.
Exactly.
With different teams, all fighting for different things.
Yeah, no trophy though, but it's all for the friendship.
It is definitely that. With that, I'm gonna bow out and let you take over.
All right. Okay. Thank you very much, Graham. All right, everybody. Yes, so you're going to be with me for the next few segments. Okay. So thanks to Julian for the previous talk. This Vault is my favorite of the stack, of the Hashi stack. So I always enjoy when anything that has to do with secrets and Vault integration. Now we're gonna jump on to the next speaker. So we have Kyle now on. Kyle's going to be, so Kyle's part of the ecosystem team at Dagger.io that maybe you've heard before. And they're working on the future of CI/CD, right? He himself has a background on DevOps and just loves giving demos, which is something I don't understand because I don't like giving demos. I like showing people things, but when it comes to giving actual demos, that's not something I actually want to do. But anyways, we're here for this. So I don't want to give away too much of the talk, but he's going to talk about continuous delivery pipelines on Nomad jobs and some Vault integration mixed in. So with that, I'm going to let him do the rest of the talk. So go ahead, Kyle.
Hey everyone. In this session, I'm going to show how you can build portable CD pipelines for Nomad using Vault and Dagger. I am Kyle Penfound. I'm a solutions engineer at Dagger, and we build a programmable CI/CD engine that runs your pipelines as containers. So first off, why portable? Like, what's the benefit of going portable here? The number one thing is you can run your CI/CD locally. So think about all that time you spend waiting when you make a commit. You push it up to GitHub or wherever your CI/CD runs, and you're waiting for that feedback of whether your commit passed or failed. When you can run your entire pipeline locally the same way it runs on your CI/CD platform, then you can have that instant feedback on the changes you've made. The other benefit of a portable CI/CD pipeline is testability. So when you make changes to that pipeline, how do you know that those changes didn't break everything or those changes are doing what you wanted to do? By having this portable pipeline that you can run in isolation, you can test the changes on that CI/CD pipeline itself as you're making them. Another big reason is to avoid CI vendor lock-in. So again, when your pipeline is something that is portable, where you can run it the same way on GitHub Actions and on Circle CI, then you're no longer locked in to a particular platform. So if you want to take advantage of one platform's features or due to business requirements, you're switching from one platform to another. With these pipelines, you won't have to rebuild your entire CI/CD environment every time you switch vendors. And then another possible benefit of being portable is multi-CI. So let's say that you want some of your CI processes running in one CI platform or another, or one of your platforms goes down, you want to be able to run on Circle CI when GitHub Actions goes down. With a portable pipeline, that unlocks that capability for you. And so if these are also beneficial, like why don't we do this all the time? Well, here's the two biggest hard things, in my opinion, of creating a portable pipeline. The number one thing, maybe it's the most obvious one, is that you have these CI-specific definitions of a pipeline. So your GitHub Actions YAML, your Circle CI YAML, they're not the same. You can't translate from one to the other very easily. And so that set of pipeline definitions only runs on one specific platform. And the other hard part is environments and secrets. So many CI environments, you've got all of your credentials and CI requirements defined in that CI platform's environments and secrets provider. And so that when you run in any other environment, whether you try to run the same tasks on your machine or move those to another project in Circle CI, you lose those things that have been set. And on top of that, managing, rotating those credentials inside of your CI platform can be tedious. And so what you want to do to break free from this is write a portable pipeline using something like one of the Dagger SDKs. And then B, you want to remove those secrets and environment settings from your CI platform. So you want to define those in your secrets provider or in something that's detached from that particular environment. And so a great example of that we're going to use in this demo is Vault. And so for this demo, here's what our application looks like. So we've got a front end, a back end. The back end is this API that runs as a service in Nomad It's a HTTP listener, so we send HTTP requests to it. It sends back things back to the client. This backend has a load balancer in Nomad as well, so that we can balance the load across all of our allocations running in Nomad. And then the front end is just the static site that we've deployed to Netlify. And if you want to check out the demo code right now, and I'll show this link again at the end, it's at github.com/kpenfound/hello nomad. So when we make a change to this application, here's what our CI/CD process looks like at a high level. So we make a git commit, and once that commit has been pushed, then it'll kick off our CI/CD processes. And so for our backend, that means we're going to run go test to make sure that our Go application is passing all of its unit tests. And then we run a go build, and that go build actually depends on secrets from Vault. And so we're connecting to our secrets provider at that stage. Once we've built our binary for our application, we want to package that in an image that we're going to ship to Nomad. So we're going to do this image build and push that to Docker Hub. And that Docker Hub push also requires credentials from Vault. And then once it's pushed up to Docker Hub, then we want to tell Nomad to update our deployment with this updated task that we just pushed up. And then for our front end, we've got it running in Netlify again. So the CI/CD process is basically running a Netlify deploy on that static site. And again, that requires some secrets from Vault as well. Our cluster in this example is taken exactly from the Nomad reference architecture, which I've actually linked here at the bottom. But it's just the reference architecture deployment for Nomad. So we've got some Nomad servers and clients running, and we've got console running in that cluster as well. And so we'll have a look at that in a second. So now that we've kind of got like this high level idea of what our application looks like, let's actually jump into the code and go into our demo. So first of all, I mentioned Dagger a few times. Our pipeline is written in a Dagger SDK. And so again, Dagger is this programmable CI/CD engine to run your pipelines in containers. And so what that means is, again, that instant local testing, so you can run your pipelines anywhere. That portability, which we're going to really emphasize today. Caching, so again, as everything's running in containers, you get this benefit of this cache behind the scenes to not rebuild things that don't need to be rebuilt. Compatibility, so you can run this pipeline on anywhere that has a container runtime. And then cross-language. So our pipeline that we're looking at today is written using the Dagger Go SDK, but we've got a handful of SDKs out now, and you can write this pipeline in whatever programming language your team is comfortable with. So hopping over to Nomad, we've got this Nomad cluster with a couple of servers here. And in our jobs, we have Fabio, which is the load balancer that I mentioned for our Hello application. And we've got our Hello application itself that has 5 allocations running. And again, I mentioned this is running alongside this console cluster, which has our load balancer and server registered as well. And then just to show the load balancer, this is our 5 tasks that we've deployed, and our load balancer is distributing load across all of those tasks in our Nomad cluster. And then that's the back end. Our front end, again, is this fancy web page hosted on Netlify. And so that when we make changes, we're going to update this Netlify deployment. So let's hop over to the code. So over here in VS Code, we've got our Hello Nomad project and our main.go. This main.go is just that API. So we've got an HTTP listener that listens on 8080, and it returns this greeting along with this secret greeting in the message. So we do this greeting with our secret greeting, and we'll get into that secret greeting bit once we go through that pipeline and figure out how we get this into this application with our build flags. We've also got the test, so again, our greeting has to line up with what we expect that greeting function to return to us. And so, like I mentioned, we've got this running on Nomad. If I hop over to my terminal, we can actually curl that and get the response back, and it's saying greetings Nomad. And so that secret is actually coming from Vault during our build step. And so if we look at Vault real quick, we'll see that at our key value store at hello Nomad, we've got this field greeting, and the value of that greeting is Nomad. So we'll see how that gets pulled into the build process once we start going through this build pipeline. So let's make a change to this and start looking at what this CI/CD process looks like. So instead of saying greetings, let's just say hello. And then we want to update our test because, again, we're testing that this matches against our greetings function. So we'll say hello. And then we'll make a change to our front end too, so we can see both of these things change. So instead of saying greetings from Netlify, let's say greetings HashiTalks. Now let's commit this and then push this up to GitHub. So we'll see our greetings have changed here, and we'll add these and commit them. So we changed greeting to hello. Let's push that up. And so when that runs, you can see in this project we've got a .github and a .circle CI. So we're going to show how the same kind of pipeline can run on both of those CI platforms as well as locally. So looking real quick at our Circle CI config, it's super brief, and we'll go through what the pipeline as code looks like after this. But again, we're going to be pushing this image to Docker Hub, so we get our Docker credentials and authenticate Docker to Docker Hub, and then we run that Dagger pipeline by just saying go run ci/main.go. And so we'll look at this ci/main.go in a minute. And that's our whole pipeline. So all we needed was Docker and a go runtime to be able to run this pipeline. And then over on the GitHub side, it's configured a bit differently with the network, so we have a few different things running here as well. But again, we've got Go. We grab our Docker credentials from Vault, and we authenticate Docker, and then we just run this Go pipeline. So let's have a look at that Go pipeline now. So here's our main function in main.go. And the very first thing here is we're going to grab a Dagger client. So we say dagger.connect, and we pass some arguments in there. And this client is what we're going to use to actually build our CI/CD pipeline using our Go SDK. And so with this client, we're going to first pass this into our backend build. So again, we've got the backend and front end that go through those different paths. Our backend here is going to do this backend build and then return, and then our front end is going to build after that. So if we jump over to our backend build first and kind of walk through that step by step, the first thing we're going to do is grab our project. So if I jump to this, we can see what that means here. We're using that Dagger SDK to look at our host and grab the work dir. So that's the local working directory on our machine where our code lives. So we're going to grab all that code from our machine, and we're going to exclude something. So again, earlier I mentioned caching. To make sure our cache is as reliable as possible, we want to exclude all these things that are irrelevant to our application build. So we exclude our CI directory, a bunch of our project directories, and the website. Going back to our backend build here, so we've got that project, and that's a reference to our Go project on our machine. And then we're going to do this multi-platform image build. So we want to be able to run this container on both AMD 64 and ARM64 architectures. So we define this build matrix of these two options, and then in our code we iterate through those two options, and for each one we're going to do our app build and then eventually publish that. So let's look at our app build, and again, this is all using the Dagger SDK to build these things. So we've got this app build function where we first build our Go application. And so we're building these containers as code. And some of these things look a lot like a Docker file. And that's because it's doing very similar operations, but you're writing these, you're declaring these containers in your Go code instead. And so we're building these on the fly. And we're saying, hey, Dagger, give me a container from the Golang 1.19 image, or the base. And then on that base, we're going to mount our project. So again, this is the reference to our local working directory. We're going to mount that project at /source. And then we're going to set that container's working directory to /source so that anything we execute in that container will be in that context. Then we set some environment variables, and by doing this in this way of like building this function that defines your whole build, you don't have to worry about redefining these kinds of things everywhere in your organization that you want to do builds. You just define them in one place and reuse this Go module. So I've defined my environment that's required for doing my Go build. I'm mounting this secret. So remember earlier, we get that secret greeting and add that to our greeting output, right? So I'm mounting this as a secret variable in this greeting. And this thing that I kind of skimmed over before is that greeting that we want to pass in from Vault. So let's jump over there and have a quick look at that. And so once again, we're building a container on the fly. This container is going to be from Vault latest. We're going to give it what it needs to authenticate to our Vault server. And then it's going to get that particular field, which is the greeting field that we saw earlier in Vault. And it's going to pass that back to us as a Dagger secret. And so once we have that greeting as a Dagger secret, we map that to our container. Our container is ready for building. The first thing we're going to run here, we're going to exec in this container Go test. So we test our application. Once we know that it's passed all of our unit tests, then we actually build our application. And so we're going to exec this Go build, and we're going to pass in this build flag to say main.secret greeting is that secret greeting that we've mounted in that secret environment. And so that when we do that Go build, that key that we just pulled from Vault in that other container, in that container running Vault, we're going to pass that to our Go build, and that's going to be in our binary. And then our output of that build is going to be this hello binary. And so if you've worked with multi-stage builds before, this is kind of what we're doing next. So we've built this Go binary in a Golang 1.19 image. Now we want to take that binary and put that into an image that we actually want to deploy to our infrastructure. So we're going to grab a new container now from Alpine. And this time, the container's platform, again, we're iterating through those two platforms in our main.go, the Linux AMD 64 and the Linux ARM 64. And so we want that container to be the appropriate platform. And once we have that platform, then we do this multi-stage build, and this is kind of the equivalent of a Docker file copy from, where we're saying, in Builder, we have this file /source hello. We want our new image that's using Alpine to have that same file at /bin hello. And then once that's in our new container, then we say the entry point of that container is /bin hello, so that we run this image. We're going to be running that that application we just built. So now we go back to our main Go. We've got our two images, the AMD 64, ARM 64, that have our built binaries inside of them. We publish them to Docker Hub, right? So we just call this, using the Dagger SDK, we say container.publish. And we're going to publish them to this address, which is my Docker Hub, Kyle Penfound /hello Nomad with the latest tag. Once those are published, then we want to tell Nomad to actually run our new image. So when we published this, it gave us back the full reference to that new image that we pushed up. And so we're going to pass that over to our deploy Nomad job function to say, hey, the hello Nomad service should be running this new ref now. And so looking at this function, we actually use the Nomad API Go client. So one of the cool benefits of writing or CI/CD in code is that, in the Go ecosystem, you can pull in whatever Go modules that you need to use. You don't have to rely on things being available in, if you're running your things in GitHub Actions, you don't have to rely on a GitHub action for a thing. Or if you're in Circle CI, you don't have to rely on an orb for a thing. In Go, you can just pull in whatever relevant clients you need to use. So in this function, we've pulled in the Nomad client, and we've configured it with our Nomad address. And we take that image reference of the image we just pushed up, and we create a job ref with that. So again, we've got this Nomad job struct where we give it the same name. This defines our whole job, but we want it to be running that specific image ref. And again, if you go to the GitHub repo, you can go through this whole job struct and look at it in detail. We'll just skim over it for now. And once we have that job ref, then we're going to talk to the Nomad API and say, register this job. And then we've deployed the backend. Once the backend's deployed, again, we want to deploy the front end. And that's actually super quick as well. So we, again, get our front end project. And if I go to that, it's similar to how we got the backend, except we're just looking at the host and grabbing the website directory. And that's it. Once we have that website directory, we want to deploy that to Netlify. So we go to this deploy Netlify section. Again, we've got two secrets, our credentials for Netlify. So our Netlify site name and our Netlify token. And we get those from Vault once again. And then we get a container that has node 16. We install the Netlify CLI on it. We mount our website at /build. And then we give this container our Netlify credentials and say Netlify deploy that /build where we mounted the website. And that's it. So that'll actually deploy to Netlify. And so that's our whole pipeline, right? If I go back here, we've done the front end, and that's it. So again, that's running in both GitHub and Circle CI. And so if we go over here and look at GitHub, here's that commit that we pushed up a few minutes ago, that changed greeting to hello. And so if we look at this real quick, we can go down and look at the Dagger pipeline, and we can see it running all of our steps that we defined in that pipeline, and it's running those for both of those platforms that we defined. And then it runs our Go test, it runs our Go build, it pushes up our new image, and then it gets the front end container build and pushes that up to Netlify. And if we go over to Circle CI, we'll see the exact same thing, but in Circle CI this time. So if we go down here, look at our Dagger pipeline, we'll see actually in this case, a lot of things are cached because I've set up Circle CI a little bit different from GitHub in a way that can actually reuse our Dagger cache between runs. And so these steps that, again, don't need to be rebuilt every single time, if nothing's changed in that cache, we benefit from reusing the caches, and it makes our CI really, really fast. And so we've pushed up our image, and we've deployed things to Netlify. And so if we actually go to this website, we can say greetings HashiTalks, because remember, forever ago at this point, this is what we changed our greeting to. And if I go back to my terminal and we do that curl again, we can see, hopefully once it returns, sometimes it's a bit slow. And this is just my particular node struggling, so maybe we'll give it a different node. And I'll say, hello Nomad. So once again, that second argument is coming from Vault, right? So let's go ahead and change that real quick. We'll hop over to our terminal. Remember that was hello Nomad. So let's go ahead and patch that to say hello HashiTalks instead. So our key now for that greeting field is hello HashiTalks. And this time, let's go ahead and run this pipeline on our machine instead. So if I say go run ci main.go, we're running the exact same pipeline that we ran in Circle CI and GitHub, and we're using the exact same credentials because, again, we're not storing those inside of our particular platform. But this time I can make this change real quick. run it on my machine, and it'll go through those same steps. It'll build that multi-platform image and push that up to Docker Hub. And then once that's done, we can run our curl again and see the updated message. So this will just take a second because we're running our go test. And our test is passed for one of our platforms. And then in a second, we'll see it pass on the other platform. Now we're doing that go build with that secret greeting, which again, we've changed to HashiTalks. And then over here, we're doing the multi-stage build with that binary. So we've gotten the Alpine image. We're putting that built binary into Alpine. We've still got the go test running on the other architecture, and that has finally passed, and so it's going to do its go build. And then once these builds complete, we're going to push that up to Docker Hub. And once it's up at Docker Hub, we'll deploy Nomad. Once it's deployed Nomad, we're going to deploy things to Netlify. And it's just going to sync that website directory with Netlify. And so that's going to be done here in a second. Just waiting for the internet. Awesome. And then if we curl out again, and now that one's being slow. Awesome. And that one's still updating, I guess. Hey, there we go. Okay, so now we've got our updated task running on that machine, and that timing worked out great because we could see the tasks switch over to our new greeting, which we've changed to HashiTalks. Again, that was just pulling from Vault and injecting it into that build. So, quick little recap because we just went through so much of that so quickly. We've built a portable pipeline. So we used the Dagger SDK. We've made our environment, our secrets portable by putting them in Vault. And we've been able to build this same application on 3 different CI platforms, essentially, in GitHub, in Circle CI, and on my machine. We've stored those secrets in vaults so that we can have one team manage all the secrets for everywhere rather than having to copy paste and have that copy paste team into whatever CI platform you're running. We've pushed that image to Docker Hub. We've deployed to Nomad. We've deployed to Netlify. And then once again, this demo code is at github.com/kpenfound/hello nomad. Thanks for watching. If you want to know more about Dagger, check out dagger.io. There's tons of information there, tons of docs. You can also get to our Discord there. That's where you can jump in, ask questions, join the weekly community call, and so on. You can see what we're building over at github.com/Dagger. And then you can see what I'm building, both these demos and other Dagger projects, at github.com/kpenfound. Thanks for watching.
All right. Let's see where we're at. Here we are. Okay, good, great. Thank you very much, Kyle. That was really interesting. I love anything that is done with code and not clicks. And I think that's the whole point we're trying to do here, especially with CI/CD pipelines. So the talk was great. All right, before we move on to the next speaker, I want to plug one quick thing. We're doing a trivia giveaway on Twitter. So follow on the HashiCorp users handle. So follow at HashiCorp users on Twitter, and then you're gonna see the instructions or the procedure there for the trivia. So hope you can join us there and snag some prizes. All right. So next up we have Joseph Rajewski. Joseph has an interesting career path according to his bio. We know a lot of people that went into law and then law transitioned into technology and coding, but that was after law school. Joseph did the law part in high school and then the transition in college. So that's quite an interesting piece of trivia from his bio. So and nowadays he works on a DevOps team that works on deploying a lot of infra-y stuff. And as he points out, his career was revamped once he discovered or was introduced into the Hashi stack, which is always great to know. He's going to give us a talk on blue-green deployments with quite a unique, not uncommon, but quite a unique stack of Waypoint, Nomad, and Console. And the reason why I say unique is because Waypoint is relatively still new, and there's a lot of use cases and new stuff to plug with and to integrate with. So having that with Nomad and Console on top of that, it's quite a unique combination. So it's going to do a demonstration of certain features around that stack and how to do blue-green deployments, which are always challenging regardless of the scheduler stack that you have. So without further ado, take it away, Joe.
And thanks for coming to my HashiTalk. Today I'm going to talk to you about how you can use HashiCorp Waypoint to do blue-green deployments in conjunction with Nomad and Console. My name is Joe Rajewski, and I'm a senior engineer here at HashiCorp on the Waypoint ecosystem team. And on GitHub, you may know me as Paladin DevOps. But before we get into how you can use all these great tools to do a blue-green deployment, just wanted to talk quickly about what it is. And it's a pretty popular deployment strategy out there in the container orchestration world. You can use it to deploy a new version of your app without taking down the older instances that are serving your customers. What this will let you do is perhaps roll out a new feature to 10, 20, 50% of your users without bringing down everyone's experience if you don't like the feature. So get to keep the uptime of the older version of your app with an easy rollback strategy where you just kill the new version of your app and keep your customers happy for as long as possible. HashiCorp Nomad lets you do this through the use of canary deployments in conjunction with tags applied to new service instances registered to HashiCorp Console. To translate that into English, what that means is when you do a new version of your Nomad job, when you deploy a new version of your Nomad job, you can actually apply new tags such as blue or green or V1, V2, V3, etc. And in conjunction with Console, we can split traffic between the different instances based on those tags. So to show a little bit of what that looks like in the Console UI, I've grabbed a screenshot here from the Console documentation. And basically through Console splitters, traffic splitters, you can route a specific percentage of traffic between DNS resolvers. So a resolver, which you'll see in the demo here later, can be configured based on tags that are applied to your service instances. And like I mentioned, we'll get to that in just a moment here once we start the demo. And if you'd like, you can follow along in my Git repo at the URL here, a repo named HashiTalks deploy blue-green. So without further ado, let's jump over into my editor, which is Goland. And this is that repo just cloned down on my machine here. And the first thing we're going to look at is the Terraform configuration, because I've written a few things in Terraform config as code, so that way when I get to this demo, I don't have to go and create everything by hand. I can just use Terraform apply to do it for me. So the three providers that we're going to use here in this demo include the Console provider, the Vault provider, because we're going to have a few secrets that are used. Optionally, you don't necessarily need to use those if you go through this. But finally, we have the new Waypoint provider that's been created by our dev advocates team. And if we step into main.tf here, we can take a look at the various resources. Let me show you. Hello. But yeah, the first resource that we're going to use here is a console config entry. And the type of console config entry that we're going to use is called a service default. And we want to basically say that the service that we're going to deploy, which is named app, we want console to know that the protocol of this service is HTTP. The default protocol is TCP, which is not how our app is going to work. So we need to make sure that console is aware that it's HTTP. And a little bit further down here, the second console config entry resource that we're going to add is called a service resolver, which I touched on very briefly in the slides. But to get a little bit more into it, this will be registered to the same service called app, and we want to make sure that we have subsets that allow us to resolve traffic based on the tag that we have on our service instances. So we're going to have a couple of subsets. One is called blue for the running existing instances of the application, and the other is called green, which is going to be from our newly deployed Canary allocations in Nomad. And this filter here is following a specific syntax, but basically this means we only want the instances with the blue tag for the tags that are registered to the service instance. So if it doesn't have the blue tag, not going to be included in the subset. The green subset needs the green. The instance must have the green tag to be considered a part of that subset. But yeah, that's pretty much it when it comes to service resolvers. And a little bit further down here, with Vault, I didn't configure everything in Terraform that I'm going to show you in Vault, but it's not necessary to do that. But I knew that I was going to need Vault to pull my Docker username and password. So because I keep that safely in there, I'm just going to pull that down at runtime when we run our Waypoint pipelines, and you'll see how that can come in handy at the time. But that's not the main purpose of the demo here. What I really wanted to show you is the Waypoint project that we're going to use, which is we're specifying the Git URL from this demo to pull down that application code for the build and blue-green deployment. So it's going to pull down the main branch, and we have the main branch checked out here locally. So we're going to take a look next at the actual platforms for which we've configured all these Terraform resources. So over here in console, we don't actually have the app service registered yet because it hasn't yet been deployed. So we're not going to be able to see that service default configuration entry that I mentioned, but that's okay. We'll get to take a look once we do deploy it. Over here in Vault, I have my KV secrets engine, and in it, I have my Docker secret with my username and password for my Docker registry. Not going to share that with you all, but just know that it's here when it comes time to run the pipeline. And we also have a database secrets engine here because maybe in a later version of my app, I want to use a database. And without elaborating further, just know that we're going to use dynamic credentials to access the database. And if I go over here to Waypoint, we can see that I have a project called HashiTalks deploy blue-green. And if I open this up and move my face a little bit and click on manage settings, we can see that it's the Git URL that we configured in our Terraform resource. And it's also specified the main branch because, like I said, we want to build and deploy main when it comes time to run the pipeline. So let's take a look at our application code. Back over here in GoLand, we're going to open up main.go. And this is a super simple Go HTTP server. We just have a handler, and once you go to the root of the application, it's going to just tell you hello world. We all know and love hello world, but that's all we really want right now. We just want to start off with something really basic and just say hello. So this is it. This is our whole application, and we're going to open up the Waypoint HCL file to see how we're going to build and deploy this application. So in here we have a few pipelines configured, and I'm going to step through those with you and after that we're going to take a look at our app configuration and how that's being built and deployed. So we have 3 pipelines. The first pipeline is called build and blue-green deployment. The first step in this pipeline is to use the build stanza that's been configured for our application. We're going to get into specifically what that is doing a little bit further down in this file once we move along here, but just know that the first step in the pipeline is to build the app. The second step in the pipeline is actually to run another pipeline, and the second pipeline is what's doing the deployment to Nomad and doing all the necessary things for the blue-green orchestration. So we can see right here the pipeline name is blue-green deployment, and that pipeline is actually defined right below it. So the first step in the second pipeline is to run the deployment stanza for the app. Just like we use the app's build stanza for the build step, we're going to use the app's deploy stanza for the deploy step. And once again, we'll take a look at what specifically is going on there in just a few minutes. But the more interesting piece here, as far as traffic splitting goes, is the second step here, which I've named split traffic to green. And this pipeline step is going to use the pipeline exec plugin to run a command that we want on an image that we specify. In this case, that image is just the console image. This image has the console binary built into it. This is available in Docker Hub, but that's all we really need for what this pipeline step needs to achieve. The command that's going to be run is just sh with -c, so we can run a script. And the first part of the script is going to curl a file for us, and which is actually, if we scroll all the way to the end here, we can see that this is actually in this repo that I've cloned down to my machine. So we're going to take a look at it, but the file that we're interested in is in the console folder, and it's named greensplitter.console.hcl. Once that file is downloaded to green-splitter.console.hcl on our Waypoint runner, it's going to then run console config write, which is basically going to do what our console config entry did in our Terraform configuration, but instead it's going to be on the CLI during the pipeline run, not through Terraform. And we're supplying the address to the console CLI, so that way it knows which console cluster to talk to when this configuration entry is being written, and we're going to supply it the config file that we download. So to take a quick look at that config file, I'm going to open this up, and we can see that this is another config entry of kind service splitter. Once again, this is registered to the service named app, and we're going to configure the splits of this service splitter to route 50% of the traffic to the service subset we defined earlier in our Terraform configuration for Blue. So as we went through at that time, that's going to be based on the tags applied to the service instances. So once this configuration is written, 50% is going to go to our Blue instances, and 50% is going to go to our green instances. And stepping back to our Waypoint HCL file here, I'm going to scroll back over here. That is the conclusion of the blue-green deployment pipeline. There's no more steps in this pipeline, but separately and independently of that pipeline, we're going to run a different one called promotion and normalized traffic. This one's going to be run after we've sufficiently tested our deployment and we're comfortable with promoting it and routing 100% of traffic to it, so that way our users all get the new features that we added. And similarly to the split traffic step, we are going to run another console image, and we're going to use sh to run a quick script, and we're going to download a config file in this repo and supply it to the console config write command once again, and instead it's going to be the normalize.console.hcl file. The normalize file, which is right here, is just saying, okay, I don't want to send any more traffic to green instances because I'm about to promote my deployment, which is going to eliminate the green instances, and all the remaining ones will be blue. And that will be the new running version of my application. So we want 0% to go to green, and we want 100% to go to blue. Because if traffic were still being routed to the green subset, those requests would essentially be dropped because there's no service instances left to handle those requests. So it's very important that this is run prior to promoting the deployment. And going back to the Waypoint file here, the final step in the third pipeline is to just run our release. And what's happening in this release stanza, I'll show you in addition to the build and deploy configurations in just a moment. So our Waypoint app that I keep talking about is just called My App. Super fun, right? But the build plugin that we're going to use is the Heroku Build Pack plugin. What this is going to do is just figure out that our app is a Go app and build it accordingly. And then the registry stanza for this Waypoint configuration uses the Docker plugin to push the image that the Pack plugin built to our Docker repository. So this is my own repository, DevOps Paladin / HashiTalks -deploy, and it's going to push the tag latest. And I'm going to use some authentication to do that. I mentioned earlier that my username and password are kept in Vault. They're being supplied here as input variables, so you can actually override them when you run your Waypoint pipeline run, if you so choose. If you'd rather not push it to a repo, that's also okay. But that's what I'm doing here. I'm using credentials to push it to my own private registry. We're going to skip over the config section here because I'm going to come back to that in our second attempt to deploy the app. But yeah, the pipeline that runs the blue-green deployment using the deploy stanza for the app is actually going to use the Nomad job spec plugin. And the job spec plugin just runs a Nomad job template file. And that file is kept at path.app, which is the location of this Waypoint file, /nomad/job.nomad.tpl. And what do you know? It's right here. So let's go and take a quick look at it. And we're not going to review every single configuration here, but the app name is being templated to the job ID. So once this is registered to Nomad, we're probably going to see that the job ID is my-app. And we can see that the service being registered is going to be registered to console because that's the default service provider for Nomad. And it's going to be a service called app. And the tags that the service instances are going to have are blue once the deployment is completed. But when we have a canary deployment, which is only going to happen during updates to the existing running Nomad job, not the very first deployment, the canary instances will be tagged green, which will distinguish them from the existing running instances tagged blue. And as you can probably start to piece together a little bit, that's going to come in handy when we need to split traffic between them. And the other important bit here is the update stanza, because we're signifying here that we want a single canary allocation. The default count is 1, so it's going to be 1 existing allocation, but we also want 1 canary allocation to make sure that we have the same amount of resources for the old version and the new version. In a production setting, you'll probably have more than just a single container running your application, but we're just going to stick to 1 here for the demo running on my poor little laptop. And further down here in our task, we can see that we're just going to use the artifact that the Waypoint build produced. Artifact is a special variable in Waypoint that you can use in the Nomad job spec and your Waypoint file, and we're going to use that to tell Nomad which image to pull. And yeah, without going through every config, that's a quick overview of what's going to happen in Nomad. And then the release stanza, which is going to be triggered during the promotion and normalize pipeline run, is basically going to promote the canary deployment. So it's going to wipe out the green instances and leave only the blue instances, which are going to be the newer version of the app. We have a variable here to optionally fail the deployment, which basically means that at pipeline runtime, we can say, oh, we actually don't like the green version. Something went wrong. We need to go back and change the code. That's totally fine. You can supply it as a variable. You can say, okay, true, fail my deployment. But by default, I've configured this to promote the deployment when the pipeline is run. And a little bit about our variables down here. You've probably seen them scattered throughout. If you use Terraform, they're not unlike Terraform input variables, but with Waypoint, we have dynamic configuration variables, and for that, or using that feature of Waypoint, I'm going to pull in my Docker username and password from Vault without having to supply it at runtime. I am supplying some other variables not from Vault, but you can also override this and give your own registry username and password if you wish. You don't necessarily need to use Vault to do this. I'm going to dance around the Postgres variables you see here for later in the demo. But yeah, there's our failed deployment variable as well. All right, I think that's enough talking about files. What we're going to do now is hop over to my terminal. And the first thing we're going to do is run Waypoint up. And we need to supply some variables. Like you saw, we have some that don't have default values and need to be set at runtime. So I have these stored in a file called variables.auto.wpvars, and I want to not prune my deployments, so I'm going to say prune false, and I think that's all we need. Let's run Waypoint up. Excellent. All right, this is actually going to take a few minutes to build the application through Kaneko to produce the Docker image, so I'm going to pause the recording here and I will rejoin you in a few minutes. We are back. The Nomad job has been deployed, and it happened after the container build and push to Docker was complete. The Nomad job name, as we expected, is my-app because that's the name of our Waypoint app, and that was templated into our Nomad job spec. So if we open this up, we can see there's my app. We have one running allocation. This is expected because it's the very first deployment, version 0 of this Nomad job, my app, and they don't have canary allocations because it's the very first. It's a create, not an update. So on subsequent deployments, we will see a canary allocation. And our service, our application is listening at my host machine's IP and the dynamic port that Nomad picked. And inside the container, it's listening on port 80. And as you probably recall from the application code, that's where our HTTP listener is also listening. We can also see here that the service app has been registered by this Nomad job to console. It's listening on our HTTP port defined here, and this instance is tagged blue, which is what we want. So let's just make sure that the app is displaying what we wanted it to. Hello world, there you go. And because I have console DNS configured on this machine, we can use the service name.service.console to also get to this address. And if I can actually prepend the tag as well, because I know that this instance is tagged blue. So if I specify the tag, then the service name, service.console, it will also take me to the same place. And that's what things look like from Nomad. But over here in console, we can go to our services once again, and we can check out app, for which we have one instance now with the tag blue. And as far as routing goes, we have 100% of traffic being routed to our blue resolver, which contains only our blue tagged service instances, and 0% is going to green, which is what we want for now. Now that we have gone through our first deployment, let's actually try and do our blue-green deployment. So to do that, we're going to run our Waypoint pipeline, and we are going to do build and blue-green deployment. Actually, before that, we want to change our application. We don't want to build and deploy the same thing that we just did. So let's go over here in main.go, and I'm going to write a ton of code instantaneously. If you just bear with me for one moment. Actually, I'm going to copy and paste some code here that I wrote earlier to connect to a database that you probably saw running in Nomad. It's Postgres, and it's going to use vault secrets through the config stanza in our Waypoint file, which I'll quickly go over once again. It's going to use those configurations from environment variables to actually establish a connection to a Postgres database and just ping it to make sure that we can connect to the database, because later on we might need some data out of that database to run this app. And it's just going to tell us if we connected successfully or not. And stepping back to the Waypoint file for a quick moment, in our config stanza, you can see all those environment variables that the Go code is expecting are prescribed here in the config stanza. So let's commit this. We're just gonna do a let's get the money and not PR it, just push it right to main. All right, commit anyway and push. Cool. We're now ready to run this pipeline. So let's do Waypoint pipeline run and pass in our vars once again. It'll be variables.auto.wp vars, and our pipeline name is build and blue-green deployment. Okay, once again, I'm going to pause the recording here to save us a little bit of time because building the image is going to take us a few minutes. So I'll be back shortly. All right, we are back once again, and the Waypoint pipeline run has completed. The rebuild of the image has finished, the deployment to Nomad has finished, and the subsequent console config write has also happened. So let's go ahead and take a look at Nomad to make sure that everything looks good. Switch over to our Nomad UI. Here's our job once again, my app. And there is still one running healthy allocation, but there's also a second allocation, which is the canary allocation that we specified in the update stanza of the Nomad job file. So we can actually come in here and take a look at our new one created 3 minutes ago, status running. And this has a new port registered to it, or a new port associated with the service instance registration. And if we click on it, we can see that we successfully connect to the database and used all of our environment variables that have been configured as Waypoint configuration, and it used that to connect to our Postgres instance. And I can do something very similar to what I did before by specifying the tag green dot, oh, I need app first, dot app dot service dot console. And we're still on the same page, great. And if I refresh blue, just to show you all that I'm not deceiving you, we can still see that this is the old running allocation, which is just printing out hello world like we saw before. And let's take a look at here over in console. So our app service now has two registered instances. One is blue, one is green. One is tagged blue, one is tagged green. And if we click over here on routing, we can see that we have our splitter, and 50% of the traffic is going to the blue resolver and 50% is going to the green resolver. So anything that is resolving to the splitter is anything that hits the splitter is gonna resolve traffic 50% to blue and 50% to green. And I think that we wanted to connect to our database if we supplied the right credentials, which Vault took care of for us through the database secrets engine, and things look good. So I think it's time to promote the deployment and normalize our traffic. So stepping back to the terminal, we'll do Waypoint pipeline. Actually, no, I can do this from memory. All right, let's go up here, build and blue-green deployment, and we're going to go ahead and run the promotion and normalize pipeline with our variables. I'm going to keep the recording going now because the Nomad job deployment time is very quick in comparison to building the Docker image. So, oops, yeah, I did get the pipeline name wrong. Whoops. All right, pipeline, Waypoint pipeline list. All right, promotion and normalize traffic. That's what I missed. All right, here we go. Let's get the money. And yeah, we're not going to run another Nomad job deployment. We're going to run the console config update first to make sure that all the traffic is getting routed to our blue instances, and then the Nomad job spec Canary plugin is going to promote the Canary deployments. So that way the new instances are the only ones that remain and are getting traffic. So there the config update has happened. All this text you see here is output from the curl command, which is fine. The Nomad Canary deployment ran, and there's all of our variables. And if we step back to Nomad, we can see we only have one allocation. The other one is complete, but the new one, this is actually the one that was deployed just 7 minutes ago, but now it's the only remaining instance. So if we try to hit green.app.service.console, it no longer is going to work. And neither should this one, because, oh wait, I could be mistaken. Yeah. This one is also not working because blue is tagged on this new instance, but it's the port of the new allocation. So if we change this to 2012, this should tell us that we connected to the database. Fantastic. And if we step back over here to console, we should check out our splitter and make sure that 100% of traffic is going to the blue resolver, which it is. So there you have it. The new feature, Waypoint pipelines, in this demo has been used to do a Docker build for my very simple Go application that connects to a database and deploys it to Nomad, updates it, and then redeploys it, and then in doing so changes the traffic that's being sent through console DNS to each of the deployments. The green, which is the newer deployment, and blue, which is the older. Yeah, this is a great these are great features of all the products. Nomad and console have been able to do this for a while. The beauty in this HashiTalk is that Waypoint is orchestrating all of this for you just through a couple of pipeline run commands and some, fancy terraform configuration, but I leave it to you to customize things to your needs. So thanks again for coming to my HashiTalk, and I'll see you on GitHub.
All right, good, awesome. Thank you very much, Joe. Okay, so that's really cool talk. Like I said, it's quite a unique. I wouldn't call it unique, maybe sort of more new-ish stack that you showed there. So always interesting, and that's kind of the point of HashiTalks deploy, kind of discovering all the new ways that we are running and scheduling and building things. So that was quite interesting. Cool. So let's move on to the last speaker of the day. Again, before moving on to the last speaker, I want to remind everybody of the giveaway trivia we're doing on Twitter for the 10 years of community. HashiCorp is celebrating 10 years of community events, HashiCorp Users Group, conferences, HashiTalks, of course, HashiConf, and everything that is around the community and not just the company itself. They're celebrating 10 years of it, and we're doing a giveaway on Twitter. So head over to let me look up the HashiCorp users on Twitter for the trivia. Also, if you are interested in speaking at HashiTalks 2023, that's the main the main HashiTalks, which is in February, I believe. I forget the date, but it's in February. Today is the last day to submit your proposal. Today. So head over to sessionize.com/HashiTalks-2023. Sessionize, SESSIONIZE.com/HashiTalks-2023. If you're on the YouTube stream, I think we can post it there, or we had already posted it there. Okay, and let's move on to the last speaker of the day. Now we have Martin Smith. Martin's an engineer who's passionate about making the world a better place through technology and also activism. He likes writing technical talks, but also likes traveling the world. He's has many aspects to him. And specifically, the talk that we have from him today is idempotency in AWS Lambda deployments. This is kind of again, not unusual, not unique stack, but it's something that you don't typically think of when we think in terms of containers, Kubernetes, Nomad, etc. Serverless is kind of its own beast, and it's usually comes with its own set of challenges. So he's going to talk about how to manage that with Terraform, both like should you do this with Terraform or not, and techniques or strategies for managing that correctly. So without further ado, Martin, the stage is yours.
So hello, good day. Thanks for coming to HashiTalks Deploy and listening to a little bit about this talk that covers Lambda functions and deploying them. So let's move right along here. My name is Martin Smith. I'm a staff site reliability engineer at HashiCorp. My pronouns are he, him. My Twitter is there, and I work on the HCP platform, the HashiCorp Cloud platform. And today I want to talk to you about something I see posts about all the time, which is deploying Lambda functions and people building solutions and make files and bash scripts and PowerShell things and using frameworks. And we're just going to explore this a little bit and look at some of the sort of traps I've fallen into, as well as maybe make a couple of recommendations. I actually worked with somebody once who asked me, they said they find the deployment of Lambda to be so painful. They said it must not be very mature. And I think that's actually the farthest thing from the truth. I think what we're really seeing is that people deploy Lambda in all kinds of ways, and some of them are inefficient, or they take a while to re-upload a file when they don't have to, or they don't upload when they should redeploy, right? That's a case of the reverse, where you're maybe in an incident and you need something to deploy and the Lambda won't. And people say, well, why is it so hard? So to do that, though, first, there are bound to be some folks in the audience who haven't heard of Lambda at this point. So I just want to talk about what it is. It is a function as a service tool So you've probably seen other of these as well. I've got some in the next slide, but it essentially lets you focus on the code that you're writing that's relevant to the problem you're trying to solve instead of spending a lot of time, I hope, worried about patching servers, setting things up, downloading dependencies, making sure something's running, managing the runtime environment for code, right? Lambda takes your code and it runs it in its own special kind of VM type thing, uses some really nice technology to do this. Check it out if you're interested. But essentially, it's like a sandbox, and AWS Lambda takes your code and runs it and does something with the results. So let's look at some details about Lambda. It's started first release in 2014. That's really surprising to me. It feels like it's made a lot of improvements, but it doesn't feel like it should be quite that old. I've listed some of the ways you can write code in particular languages. They have multiple runtimes. For a long time, you could sort of use one of those to bootstrap your own language, but now they support custom ones directly. So there's some competitors there of other folks building similar runtime models. What else? It's event driven, so that's kind of interesting. You can listen to things that are happening maybe in other parts of your infrastructure, your application, and run a Lambda in response to them. It can run inside your VPC, but it can also run not in your VPC. That was the inside the VPC thing was a feature that was added more relatively more recently. It has multiple architectures, so you can actually run x86 and ARM Lambdas. It also supports quite a bit of code. So in theory, you can upload 75, I think in 250 meg layers, you can upload gigabytes of code, 75 gigabytes. It also has a free tier, which is first million requests are free, plus the amount of compute time. It's in gigabyte seconds for the free tier limit. Another interesting thing is you can purchase savings plans for these, so you can actually save money if you run a lot of them. So they're a really viable option for certain types of applications or solving certain types of problems. One limitation of them I could mention is that the memory and CPU is tied together. You don't necessarily pick them separately. You pick your memory and then you get a corresponding amount of CPU. There actually are other disadvantages to Lambda, but I'm not really trying to sell you on Lambda per se. So check it out. It may work for your use case. And yeah, let's take a look at a particular use case. So this is a way to make sure that S3 buckets have logs on them, right? And they go to a log bucket of access to the S3 bucket. So what you're seeing here is Terraform or from GitHub with AWS CLI, you might deploy this enable bucket logging.py Lambda function. It sits in an S3 bucket itself. And on an interval, it says cron job here. We're talking about, I believe, CloudWatch events. It's going to run and it's going to look at all the current and new buckets and make sure that they're configured by just enforcing the settings on every bucket. And so there's also a use case for log shipping, which you see at the end here, which is you can actually configure a Lambda to run every time a file is put in an S3 bucket. And if you do that, you'll get that Lambda running and you can decide to ship that log somewhere else. Maybe you use Datadog or something that's not CloudWatch logs. Other examples, you can directly invoke a Lambda from the command line or actually from Terraform, I learned recently. You can have it being put on the internet and invoked by an HTTP request, either directly through Lambda function URLs, or you can put it behind an API gateway. That API gateway option has been around a little longer than directly addressing Lambda functions by URL. You can also have an SQS queue, and you can have that SQS queue every time there's something in it, you can run the Lambda. Some of the use cases for this, you could build a whole website around this. You could build some of that file processing type logic I talked about before. You can implement backups on a schedule where maybe some AWS product doesn't support backups or one of your products doesn't. support automatic backups, you can actually just do that Lambda on a schedule to perform the backup, or maybe invoke the manual backup or snapshot option in some project. You can use it for stress testing. It has some concurrency limits by default, but it can go quite wide. You can also use it for, I really like this solution, CloudFront Edge processing of requests coming into CloudFront edges. So you could actually like look at a header when a request comes into a CloudFront edge and decide to perform a redirect or set another header or do something with a request, and that's running on the edge near the user. So that's really cool that you can use Lambda to do that. You can also do custom CloudFormation resources with Lambda. So you can say, make up your own resource in CloudFormation and just back it with a Lambda. And again, there's a lot in there that I just mentioned, but some of them are maybe not great ideas too, depending on the architecture. There are downsides to Lambdas, like its 15-minute runtime limit. So I'm not trying to say that it's all perfect or that give you a big comparison here, but I just want you to understand maybe why folks are deploying Lambdas. So let's get into some of the simplest use cases for doing so. And so I want to just talk to you about how folks might deploy Lambdas. I'm going to show you some examples, but just a disclaimer. I ran all of these examples, but I'm not running the demos live here. We only have 25, 30 minutes. So verify this. You don't want to find out that I've edited something in a terminal. It doesn't work the way it should. So please go play with this, try it. I might eventually upload some of these files into a public GitHub repo. But again, no live demos here, trying to keep the time down and avoid the live demo gremlins. So here's what I want to show you first, which is just deploying a Lambda function from the console. You actually do a lot from the console, and the Lambda console text editor is like a lot better than it used to be. It even has tabs now, if you see that in the screenshot. It wasn't always that amazing. You could do a lot in the console, though. You can configure it, you can monitor it, you can look at metrics from it. But one limitation is that the console's not going to load your Lambda if it's more than 3 megs. And as soon as you include some dependency for Node.js, for example, you're going to hit that 3 meg mark. Here's also an example. It's the first time I'm showing you what a Lambda function actually looks like. And so you can see here, there's some event data, and then there's context, which is about, which contains information about how the Lambda was run, maybe like when it was started, so that you can check and see that it's not running too long. Maybe I forget all the things that are in there, but there's a whole bunch of stuff about where it's running, maybe the region, stuff like that. And then you can see that all this one is doing is returning some arbitrary data as JSON, and that's it. And as long as it doesn't throw an error, it can print things to standard out. It can do all kinds of stuff as long as it doesn't throw that error. And you'll get this back. And I'll show you how could we upload this if we didn't want to use the console. Say we do have the 3 meg limit in play for us. Here's another example of a Lambda function that's actually looking for something in an event. Even when you invoke a Lambda function synchronously, you can provide that event. But again, the event data there is user input, and the context data is typically all AWS provided information. This one just does some message formatting, returns a string, and it does spit the user input back out if you provide that certain value of first name. So here's the directory we put it in. I put it in a file called lambda1.py. I put it in a Python directory. There's some requirements in case I want to do additional dependencies. And here's me just zipping it up, calling it lambda.zip. You can see it compressed really well. It's not a particularly interesting file. And then what about if we were to update or create that function? Here's an example of that. I'm not showing you the create, but it's really similar. It has a few more arguments you need, but as you can see, really the update is very simple. You just supply a function name and where the zip file is, and that just kind of works. Let's see here. What do I want to show you next? Invoking the function is what I think is an interesting example. So you get this status code out of it. You can see my the output of that one had my message in it. So you get like all kinds of information about whether it succeeded, whether it had a stack trace, when an error, all kinds of stuff. But you can invoke it by name. Lambda functions also have versions, which I'll talk about later, but it's more of an advanced feature of it. So you can actually even specify the version of the function you want to invoke. It's nice for rolling back. But command line things are great, but we want to do something with Terraform because we like infrastructure as code. We like to do code review, pull requests, big fan of consistency. If you have a lot of Lambda functions, I'm not wanting to type all that out manually. It's much faster to do that through automation. And it scales better to lots of functions, right? So I just want to kind of show you the resource here. There's an IAM resource I'm not showing you, which is needed for the Lambda function to run as like an IAM role. I'm not showing you that, but it is there, and I have it in my code when I'm running this. I just want to walk through the actual Lambda function resource itself a little bit. So it takes a file name. It has a function name, which is mostly used to display in the UI. It has this IAM role I mentioned. It has a handler. You can see Lambda 1 was the name of my Python file, and then Lambda handler was the name of my function in that Python file. You can see I chose a particular Python version too. Lambda has a bunch of ones built in. So that's that resource. What does it look like when you run this with Terraform? It looks like this. It says it has 2 resources to add. You can see my IAM role there. You can see the function after 6 seconds. Boom. Here it is. That was pretty easy. So I think this is the first time people start to get confused about Lambda or run into little pitfalls, right? So I want to show you updating your Lambda, which is just a Terraform apply auto approve. It says no changes. Your infrastructure matches the configuration. That's great. I hadn't updated the Lambda yet, so that's fine. That's what an update would look like, and there's no change. So I'm gonna modify the Lambda. And again, this is where I think folks start to run into trouble, is very simple modification here. I'm gonna do that same step I mentioned before where I zip up my Lambda into this lambda.zip from that lambda1.py. And I'm gonna run Terraform again, right? Just a slight modification. And it says no changes. And so I think maybe it's partly the AWS provider, but it's confusing that this says no changes. I literally just updated that file, and then I zipped it back up into that deployment object, the lambda.zip, and it should be there. So, I think the first time I saw this, I thought, well, maybe, what if I just delete it? What if I just delete it entirely? Surely that's going to break something, right? Surely that will. So we're going to run our Terraform apply again. No change. So, darn that. What's going on here? This file doesn't even exist, and Terraform says, you're up to date. Everything's good. That's pretty confusing. So I want to kind of dive into the Terraform provider for AWS and see, how does it decide that something has changed? And I found this one function. I think I've trimmed this one a little bit, but I kept the important bits. And you can see here that these are the things that detects if the Lambda function needs the code package shipped back up to it. If the file name is changed that I'm shipping, so I didn't change that. Mine was lambda.zip. Has the source code hash changed? Turns out that's not something computed automatically. You just have to supply that if you want that one to be set on the function. So I didn't supply it, and it doesn't seem to be calculated, so it's probably not changed. I'm not using S3 to deploy my Lambda. If I was, these changes would matter. So kind of nice if the S3 object version changed. So if you had versioning on your bucket and you uploaded something, if S3 detected it had changed, you'd get a change. And then some other ones here, also ones that you would expect to cause a change depending on your Lambda deployment model and so forth. So let's use source code hash. It seems like the most viable one. I don't really want in my system that I'm building here to change the file name to have the timestamp in it every time or something. because I actually do want it to be the same when there's no changes. So let's do the source code hash. And here's me adding it, right? Pretty simple. Now, when I modify the file, I can see that I definitely got a new apply. And I don't show you that here, but I'll show you that in a slide or two. Here's one thing I did just because I was curious. I used this base 64 version of the SHA-256 hash of the file, but I wanted to kind of check it, right? This is relatively new in Terraform. I think it was added in like .11 or .12. So I wanted to see, like, is it me? Is it, am I the problem? Is it the zip file? So I just wanted to kind of zip the file back up, and see, is it reproducibly the same SHA-sum? So turns out if you don't modify the file, yep, exactly the same SHA-sum. You can see it here. It starts with 6226. And so I went ahead and I did that apply here, and with the checksum that I put in place and that I showed you 2 slides ago, this file base 64 SHA-256, I don't get changes when I don't make changes. That's what I wanted. But I did want to see, well, what happens if I do make changes with this new checksumming? And so I just touched the source file. I thought, well, maybe that'll make a change. And it did. You could see the SHA-256 sum here changed. If we touch the file, if we update so much as a timestamp, we're gonna end up seeing a deployment every time because the SHA has changed. And I just want to, as an aside, remind you that, like, it's a fact of life in CI/CD systems that sometimes timestamps on files change even when the contents haven't. And if not that, sometimes even just you're cloning a repo and you might even see that. So what happens when there is a change? You can see here that it shows the source code hash as a base 64 value, and it shows that it's going to change. I touched the zip file, or excuse me, I touched the Python file and zipped it back up. And that made the zip file checksum different. So cool. I don't want just a touch to update it. So what can I do instead? And I'm going to use another Terraform provider here that you might want to consider using if you're building your zip file yourself right now. And that's archive file is the name of the resource. And I'm going to just say, please zip up into this lambda_function.zip file, which is a slightly different name. I'm going to switch from lambda.zip to lambda_function.zip. And here's my directory with that source code in it. So I'm going to implement that. And I'm going to do it also. I'm going to make some modifications. Before I just had a file name here. Now I'm actually using the archive files output for that file name. And it also is going to give me the sum of the base 64 SHA-256 checksum of the file it's created. So that's great. That's actually what I was looking at before with that inline function. So perfect. Does that work any better for, say, deleting a file and then having Terraform tell me nothing has changed? And in fact, it does. I can actually touch this file over and over, and I can do the apply, and each time it says there's no change, which is interesting because before I touched it, I touched the Python file, but I could even touch the zip file, and because it's SHA-sum hasn't changed, nothing has changed. Now, what an archive file is making these zip files suddenly be reproducible or idempotent, right? That's in the title of my talk. What's making it consistently do the same thing? And if you dig into the archive file provider's source code, you actually find this line, set mod time to this empty value. So that's really interesting. So somewhere at some point, somebody decided that's maintaining this provider that we're actually going to always make more reproducible zip files. So hope you're not using this provider for some place where you actually need a modified timestamp of your files inside the zip file. But in Terraform, archive file just does that. I don't even know that it's that well documented, but that goes a long way if you're going to use this to build deployment artifacts for Lambda. This goes a long way to making them more reproducible, which is great. This also has the effect of if you delete the file, it notices. That's great. We wanted that. And also, if you haven't made any change to the Python file as we hoped. The zip file has the same checksum, and so we're good. But I wanted to kind of dig into like the history of this. I was really curious, given that I've seen for years people stumble on how they deploy Lambda functions. So I went and did the sort of git praise, git blame version on GitHub. They've got their little button for that. And I went and found the issue. And here's the issue, the bug report filed, where check out this quote on it. But somebody reported this and noticed, hey, it was saying that a zip file was like changing and re-uploading before this with the archive provider. And this quote says, I wouldn't recommend using Terraform as a build tool, whether you're making a binary or a VM image or a Docker container. It's just not designed for that. There's better tools. So it's so interesting that, I see this a lot in the Terraform community is that someone says, oh, you should do that with Terraform. You shouldn't do that with Terraform. You shouldn't use it as your Kubernetes deployment. You should use Argo. You should use it to template all of your Helm files or what have you, right? So there's really different opinions about it. And I'm going to share mine in a minute, but I do think that there's a time and a place for using Terraform to do your deployments, especially when you're deploying software that's connected to the infrastructure in some way. So if it's actually part of the infra, great, deploy it that way. If you're deploying an application and has nothing to do with the infra and you don't want to have your app changing or your infra changing when you're modifying the other, deploy it a different way. All great. I think what works for you is best here. But I wanted to tell you about some of the other things that I've seen here, like other tools that are not just Terraform and how they handle some of these situations like we just looked at. So I don't think I've mentioned this yet, but AWS has a serverless application model, CLI. It's built on CloudFormation, and so it actually uses CloudFormation change sets to detect that some things are changed. And it also does this thing where it says, I guess it used to use checksums of zip files like we just showed you, but now it does directory checksums, which makes sure it even has semantics for like whether a symlink means a directory is changed, but it does look at the file names and their contents as well. Another tool, serverless framework, actually does this thing that I've written here, which is it takes all of the hashes of all files in the deployment. So it's actually building the zip file, if you will, or whatever kind of deployment you're making. And it's checking the hash of each individual file, and it just halts. But they do need to provide a way to do this. So they have force. And then serverless is also based on CloudFormation. And so they also have a way to say, hey, just update the function, don't update the CloudFormation. So there's another layer of like change tracking and change control. And so one of the reasons I wanted to give this talk is that I keep seeing this pattern come up again and again of the idempotency of zip files or of various kinds of build artifacts, right? And I mentioned a few here on this slide, which some of them really crack me up. Some of them go way back to when Perl was the dominant language. Even some of them are more than 20 years old. We got Python versions of it. We got ones as utilities in Debian. We have Golang implementations. There's also all of these like uploader CLI tools. I mentioned one there, the Lambda uploader, which I actually worked on in 2012 or 2013, something like that. And then I mentioned these two I just talked about a second ago as well, the serverless framework and the AWS SAM CLI. But I can't tell you how many times I see, whether it's a subreddit or somebody in a forum asking for help, or in Slack, on a community Slack, or somebody saying, Lambda's not deploying the way I want. And so I think a lot of it goes back to this like idempotency of build artifacts problem, which I find super interesting. There's also the AWS SAM CLI that I just wanted to show you an example for, where you could actually do multiple Lambda functions. And I'm going to mention that again. It can deploy tons of functions. It's based on CloudFormation. This is an example. And it can even pull lists of functions from other files. So like really geared on having a nice deployment instead of maybe Terraform, which is geared on reproducibility of environments, right? And that's a simplification, of course. here's using GitHub Actions with it, and they actually supply some nice GitHub Actions too, and you eventually run a build and a deploy. These are vastly simplified because these YAML files were way too big. But you can see how this starts to turn from Terraform resources for Lambda functions, which are like first-class objects, to simply data. And so I like the idea of, if you're building a lot of Lambda functions, you really want to represent them as data, not as behavior or code, right? Here's another example of the serverless framework, and it's YAML, very similar looking. I've again removed some stuff here too. The GitHub action is almost identical for the serverless framework example. They provide very similar ones. So we're kind of coming up on time. I want to just take a moment to zoom out and make some observations about if you are thinking of using one of these tools, and if maybe you will run into one of those problems like the build item potency. I think there are probably a lot of other interesting ones I could propose another HashiTalks deploy on. But I just wanted to sort of put some tiers or categorizations here. So a lot of folks are just deploying a handful of functions. They don't change often. They're often about the infrastructure. They're doing basic monitoring. They're looking at things like, does the Lambda invoke successfully? How long does it run? And what's the error count in the metric on CloudWatch? And for that, I really think that doing the archive file zip up and deploy with Terraform makes a lot of sense. I think this is not something you're going to want to do a bunch of scaffolding for if those are your only Lambda functions, and you're not going to have, but maybe, I don't know, maybe you ship a change once a month, right? Like, you don't need Lambda function versioning. You may not actually need some of these more advanced deployment methods at all. This will probably solve your problem. A lot of infrastructure I see is deployed that way. That has a Lambda function to do one thing. Then there's sort of like a middle tier where I would say, like, maybe you're using it to actually do application logic functionality. I think it's fine for it to live like along an application, maybe in a GitHub repo, or a separate repo for Lambdas that is just all your Lambdas that you're versioning and releasing together. You might be doing more like things like test coverage. This is where CI/CD starts to come in. Maybe you're thinking about using the like Docker layer functionality instead of the zip files, but it's not infrastructure, or it's not as much infrastructure. And also I mentioned here, there's actually a really nice Lambda community module for Terraform that deploys Lambda. Shout out to the folks that maintain that. I know some of them, they're awesome. And that might be all you need. It has some more advanced features. But you don't necessarily still need a bespoke build tool just for this. This is where you might start doing things like monitoring whether your function is throttled or have concurrency limits that it's hitting because you're getting too many requests. This might be where your Lambda, as I mentioned at the beginning, is reading off of an SQSQ. Check out the community modules in the Terraform registry. It's registry.terraform.io, but there's some really good work there. And that might be enough for you if you're kind of in this situation. Now, if you're building entire serverless applications with many Lambdas, you might be building it to actually, we talked about that example of putting a URL in front of a Lambda. You might actually be using it for customer-facing work. This is where I would recommend you start thinking about tools like the AWS SAM CLI or the serverless framework. This is where you probably don't want to be using Terraform or CloudFormation. You want to be doing more CI/CD tooling to call those CLIs. Normal SDLC applies here. You're going to be just doing regular code review and deploy like you would for any other application. It should have a GitHub repo like any other application. This is where you might also start considering things like monitoring. There's a metric for Lambda to fail to write to a destination or has a DLQ from SQS. This is where you might want tracing. This is where you might want to have your own metrics you emit from your Lambda. So again, you might also want to do more advanced deployment like blue-green or version pinning in the Lambda API. Those are both really advanced things that you might need if you're at this stage. So I'm going to stop there. I've talked a lot. I really appreciate you watching this talk and learning a little bit about how to deploy Lambdas with me, and maybe take away some tool recommendations, or at least I've stopped you from stepping in a potential pitfall. So yeah, thanks again, and good luck to all the other HashiTalks presenters and the MCs. Thanks so much.
Okay. All right. Thank you very much, Martin. That is it for today. This is the last session of today. Join us back tomorrow at 10 a.m. Eastern for day 2 of HashiTalks Deploy. We have another day, a packed day today. Another packed day tomorrow of talks and presentations. I think that's it for me. Again, a reminder that we're doing the giveaway on HashiCorp users on Twitter for the 10 years of community, and also the reminder, if you're interested in talking on HashiTalk, the main HashiTalks in 2023, today is the last day for submitting a proposal. That's it for me. Thank you very much. Have a nice rest of the day, and see you tomorrow. Goodbye.